Hello, everybody. We are live. So welcome to the EMEA live stream for Azure Cosmos DB Conf, the first conference for Cosmos DB. So Azure Cosmos DB Conf was organized to provide a live stage for global Cosmos DB communities to share and discover each other. So over the next 3 hours, you will see and hear from customers and community members who have built some amazing apps and services. And they're going to show you what they've built and what they're learning, what they learned building on Cosmos DB and for the cloud. So you'll hear from partners also who have built tools to make building applications and services with Cosmos DB better and easier overall. So I'm Theo. I'm a PM on the Cosmos DB team. I want to introduce a couple of my colleagues, Gal and Stefani. They're also PMs on the Cosmos DB team. Gal, do you want to take us through the format today?
Sure. Thanks, Theo, for the introduction. Hi, everyone. I'm Gal Levy, and I'm a PM on the Cosmos DB team. In this last live stream for the Azure Cosmos DB Conf, we'll hear from community members from across the region. If you missed any of the live streams, don't worry. We will have these on demand available shortly. For each of these live sessions over the next 3 hours, we'll have a live Q&A link for Q&A with the speakers. If you'd like to ask questions, be sure to join the live stream on Learn TV. And now Stephanie introduced our first speaker.
Yes, thanks everyone. Thanks, Gal. I'm so happy to be here. So super exciting to be here with our first conference. So first off, we're kicking things off with Mikhail Shilkov. He's from the Pulumi team, and he's going to be telling us about building modern infrastructure for modern apps.
Hello, friends. Happy to be here at Azure Cosmos DB conference and to talk about modern infrastructure as code and how you can apply it to Azure Cosmos DB and other cloud systems that surround it. So let's jump to my slides. When you use Cosmos DB in your systems, you combine it with many other components as well. You develop your applications that are deployed to the cloud compute services, let's say Azure Kubernetes services in my demos today. Maybe those applications are structured as microservices with all the machinery that you need to run that. You use also other managed services, maybe in multiple geographic locations, because that's the strong side of Cosmos DB, or maybe even across multiple vendors. In any case, you need to deploy those applications and infrastructure components, of course. And today I want to show you how you can use, for example, C# to provision cloud resources. And I'm a software developer working on an open source tool called Pulumi, which allows you exactly this: deploy Azure Cosmos DB and all the parts of your applications from .NET or other programming languages. So three cool things about Pulumi that I want to emphasize today. First is that if you come from a developer background, you can use all the skills, tools, and habits that you already have as a developer. Now, my demo is going to be in C#, but that's just because I needed to pick a language for the demo. You can also use TypeScript or Python or Go, your favorite language, in your own projects. With that, I want to show how developers and operators can and need to work together to be productive in today's complex cloud-native world. And finally, with our APIs, you get access to full API servers of both Azure and Kubernetes, full coverage of all the services and features as soon as they are released by Microsoft or by the Kubernetes community. So let's get going. Azure has dozens of services and hundreds of resource types. And this slide just shows a small subset of them. To create all of those, of course, you can get started with Azure Portal or the Azure CLI. These are great things to explore stuff, but they are not a great option for production deployment because they are very manual and hard to reliably reproduce over and over again. Looking at Azure Cosmos DB is a great example of the breadth of features and management aspects that you need to take care of. You have to manage accounts, databases, collections, APIs. If you are more of an IT or DevOps person, you control things like replication, networking, security, backups, scalability, monitoring, cost, you name it. As a developer, you're probably more focused on fine-tuning your collections with indexes, deciding on consistency levels, managing data flows, integrations with other services, and so on. So it's a bad idea to use ad hoc manual approach to manage all of that in the real production applications in real organizations. Instead, you may have heard of infrastructure as code, where you describe your resources, your cloud resources, in some machine-readable format. And then there is a tool that deploys the resources for you from your definitions. You may know of ARM templates where this machine-readable format is JSON. There is now also Bicep, which introduces its own DSL language. In Kubernetes, that would be YAML files and Helm templates, for example. What we at Pulumi suggest is that you modernize your approach and start using programming languages instead of text files. The benefits are, for example, using the rich toolchain that are used to, like compilers, IDEs, refactoring, and so on, that I'm going to show in a demo. And then importantly, you can create reusable abstractions like functions, classes, libraries, share them with your colleagues and the larger community as well. So you can do even things like unit testing with your code for your infrastructure programs as well. How cool is that? Pulumi supports multiple cloud providers, AWS, Google Cloud, and others, but our Azure Story is special because just yesterday, actually, we introduced the general availability of our native Azure provider. It supports all of our languages and runtimes, but even more importantly, our SDKs are automatically generated from Azure Open API specs that Microsoft publishes. That means that you get access to all properties of all resources of all Azure services as soon as the specs are publicly released, literally on the same day, sometimes even like before they are released, actually. I suspect you haven't heard of the Azure Web PubSub service. Apparently, that's a vNext service for SignalR, which is not yet announced as far as I know, but we already have APIs for it because Microsoft already published the Open API specs for it the other day. And we also have a tool where you can take an ARM template and convert it to a draft of your C# or TypeScript program that you can then adapt to your needs with a low effort. So here is my first example of how we can define Azure resources with C# in Pulumi. Each resource is basically a constructor call with a name and a bunch of properties. In this case, I define two cloud resources, a resource group, a container for other resources, and the Cosmos DB account. Note how I use lots of enums here instead of like magic strings that you would use in JSON. And this is all compile time checked. So if you make a typo, you will get a compiler error and it will be immediately apparent in the ID. Also note how I use the resource group variable in the definition of my database account class. And that usage by itself creates an automatic dependency between resources. It's not the order of statements in my program. It's not imperative code. It's declarative sort of that defines the deployment order. It's just those dependencies through the variables that define the actual deployment sequence. Now, a lot of companies these days also use Kubernetes as their application platform. With Pulumi, it's the same story for Kubernetes as for Azure. You can manage 100% of your API surface of Kubernetes, and you can deploy actually both Azure and Kubernetes from the same program, as I'm going to show in the demo. And all with the safety and pleasure of working with .NET or your favorite runtime. So actually, these are all my slides for today, and the rest is going to be my demo. In the demo, I'm going to use .NET 5 and C#9 to define a Pulumi program that provisions an AKS cluster, a Cosmos DB account with MongoDB API. Then it deploys a to-do app with a Helm chart that uses that Cosmos DB as a data storage. It's a to-do app. Obviously, it's a very simplistic version of real-world applications. But as you can see, there is already a bunch of moving parts that I have to manage and integrate correctly. So I'm switching over to my Visual Studio, where I have I hope you can see it. Yes, you can see it now. So I'm on my Visual Studio where I have a C# project bootstrapped, and it's a normal .NET 5 project and executable program. And you can see that I have a bunch of NuGet references. They are all from Pulumi, different providers of Pulumi. One can Azure, manage Azure resources, one can manage Kubernetes resources, something to create Azure AD accounts, for example, SSL keys that I need to create a Kubernetes cluster, and so on and so forth. So my program is empty at the moment, and I have a couple of snippets to avoid typing and sort of get going faster. At first I just define my program. I use a bunch of using statements to get all the packages right. You can see I'm going to create a bunch of Kubernetes objects. And then I'm using the top level statements as my console application code. And all the program just consists of one line, basically. It's saying, Pulumi deployment run async, and please deploy the stack that I define below. And stack is a class which derives from base class stack from Pulumi namespace. And this is the constructor, and I need to define my Azure resources in here. So my first Azure resource is going to be a resource group, of course, because I need to provision other resources. And that's all I need to define a resource group. I just give it a name. I have a config file already on my machine that says that my default location is West Europe, where I reside. So that's all I need to start deploying my application. And actually, I can now switch over to PowerShell console. I'm on the folder with that project that I just created. And now to deploy this code, I need to type Pulumi app in my console. Maybe I will make it a bit bigger. And then hit enter, and then Pulumi runs. It compiles the program that I just created in Visual Studio, and then it will run it as a console application. And it will get the definitions of resources that I have there, and will show me the preview. So nothing is being deployed yet. It's just, oh, okay. So I don't have, that's a good thing. I don't have location configured in my config file, so I need to run another Pulumi program that will say that I'm actually in West Europe, so you can see how it's done. Okay, I'm now in West Europe. Let's try it again. Pulumi app again, it compiles again, runs my code, and will again, this time it should show me the preview of which resources are about to be created in Azure. Yes, I can see that it wants to create sort of two things. One is just a stack that is like a high-level container of my resources. It doesn't create anything in Azure. And then the second one is a resource group. This looks good to me, so I hit yes. And this time my program runs again, and Pulumi will go ahead and actually provision resources in the cloud for me. So it should create a stack, which is no open in terms of Azure. And then it creates a resource group, and it took me about 9 seconds to do all of that. Okay, this looks good. Switching back to my Visual Studio. After resource group, I want to provision my Cosmos DB, of course. So I have a snippet that creates a Cosmos DB, MongoDB database, because that's what my application is going to expect. It expects a MongoDB. It actually doesn't know that's going to be Cosmos. So I just provision a MongoDB API for Cosmos, very powerful feature. And then I can go proceed with deploying my application. Okay, so I defined a new resource, and actually it's not one resource, it's two resources, and I have a helper component here in my program. It's not a class, and it's a good demonstration of how you can create abstractions in your own code. So I created a class which does the nitty-gritty details of provisioning a Cosmos DB account with all like offer types and kind of MongoDB, and defines a consistency layer and so on and so forth, locations where I want to deploy. And then the second resource is the database that I need to create for my to-do app, and it's called to-dos, of course. So now when I edit this component call to my program still looks very simple, so I can reuse this class over and over again. I can switch back to the CLI and run Pulumi app again. And this time the same happens. It runs my program. It will see that now I define two resources. One is a resource group, actually three resources, a resource group, a Cosmos DB account, and a database. And it compares that definition with the previous deployment where I already have a resource group deployed to Azure. it now shows me the difference between what I have in Azure and what I have in my program. And the difference is that it's going to create a database account and a MongoDB database, and it will not touch my resource group because it's already there. So I don't have to write, like, I will hit yes to start the deployment. I don't have to write like migration script from state A to state B. I just keep adding more and more resources to my program, and then Pulumi takes care of the state and comparing the previous state with the next state and figure out the best path forward. And that's a great difference with, for example, using Azure SDK directly, where you would have to like create an imperative step-by-step program of what exactly to be provisioned this time, or versus like upgrading from version A to version B. While in Pulumi, you define desired state configuration, where you keep adding more and more resources, and then the state is taken care of by the CLI. So actually, as you may know, provisioning a database account takes about 5-10 minutes, I don't know. So I'll leave it running here, and we'll go back to Visual Studio to complete my project. So next thing that here is a AKS cluster. I have another component that abstracts away some nitty-gritty details of provisioning a Kubernetes cluster for Azure Kubernetes servers. It needs like SSL keys, Azure AD applications, some other resources, and of course the managed cluster itself. But it's all hidden in this component that I created, and it just need to pass a resource group, Kubernetes version that I want, node count, and node size for my pool. That's about it. And now I can start provisioning resources to the same to this AKS cluster from the same program. One of the outputs of that component, if I type here, you can see that I can use an IntelliSense and everything, is going to be kubeconfig. And that's the kubeconfig that's going to be calculated after the cluster is deployed. And I can use that kubeconfig immediately, even before the cluster is deployed, to start creating Kubernetes resources here. For example, I need to put a connection string somewhere. So I create a Kubernetes secret that contains a string of my connection string to the Cosmos DB MongoDB API. And you can see I'm using a function here, C# function, to format that connection string. And that's another benefit of using C# or other general programming language, as opposed to JSON. You can just write a simple function or a class with methods, as you would do in your application, and do whatever you want there, format strings or load something from external configuration file, or make a call to the external API if you want, and like format the thing that you need to deploy as a secret in the Kubernetes and just assign it to a property. And then the next step is going to be deploying a Helm chart. There is a Helm chart, just a demo Helm chart by Bitnami that deploys the to-do app given a MongoDB connection string. And in this case, I say that, hey, it needs a value called external DB, and I will point it to the secret that I created on the previous step, and it will read the secret value at runtime from the Kubernetes when it runs in Kubernetes, and we'll create a load balancer in front of it, and it's going to be my application. Instead of that, you could deploy your ASP.NET app or whatever kind of application you create to connect to Cosmos DB. This is just very easy to demo. And then the final step in my program, I'm almost done, is to export the URL of the resulting application, of course. Like I can get it from a service object in Kubernetes, take its load balancer, ingress IP, all of that with C# again, all with types and IntelliSense. If I make like a typo here, it will complain that there is no property in toGress. And so I get a very fast feedback loop while I'm developing code for this. And I can be confident that it sort of works before I even start deploying. And then I assign that IP plus an HTTP to the endpoint output, and that's how I define the output of my program. So when my deployment is done, it will print out the endpoint at the end of the deployment, and I will be able to use it immediately after. So that's it. That's a complete program. I'll just hit save and switch over to the CLI. Let's see if, yes, Cosmos DB actually provisioned. I was lucky it got created in 4 minutes. So I can run Pulumi up again. Now it compares the state, the previous state, of my deployment with the database versus the current program, and it should figure out that it should deploy an AKS cluster and a bunch of Kubernetes objects to it. Let's see what the preview shows real quick. You can already see it computes. Yeah, okay, I'll scroll up a bit. So it has like a AKS cluster with a managed cluster in container service. Also, it has a Helm chart that I defined and a secret that I defined with connections. So this looks good. I'll hit yes, and I don't have time to wait for AKS. So I'll just switch over to the next tab in my PowerShell, where I had the same deployment but already done and finished. It will take about 3-4 minutes more. So in the end, all this is created, and you can see that the output that I see here is the endpoint to my application. And if I switch over to the browser, this is the to-do that we deployed. And like if I do something add here, this is stored already in Cosmos DB that I just provisioned with my C# code. All right. So quickly back to the slides. So that was the case where I deployed all the components from the same application, from the same program in C#. In practice, it's not likely that the same person in your organization is going to deploy all those things at the same time. So what we see more in the larger companies or even in smaller companies with multiple teams, that they have some specialization there. Some people work on like underlying things like Kubernetes clusters, but also security, networking, storage, monitoring, scalability, multiple environments, creating guard layers for their developers. And these are like platform teams that are working on the internal platforms for their applications in the company to be deployed. And then application developers, they usually don't really want to care about all those details. They care about the application code, the data that they manage, like messaging, login, performance, and integrations with different services internally or externally. So there are multiple roles. And how this translates in Pulumi is that probably a platform team will create a stack or multiple stacks where they define all those low-level details, and they will deploy them on their cadence when they want and with their permissions and their credentials. And then they will share something like kubeconfigs and other connection strings with application developers, and then they can import it and sort of based on that deploy their Kubernetes services, deployments, and so on to the clusters that were already provisioned and ready to go. And even with Pulumi, platform teams can create like the components like I showed you, where they create the blast configurations of application deployments, for example, and then they can share it as a NuGet package internally or to the community, and the application teams will be able to get started quickly and use those in their applications. Last very quick demo for the 2 minutes that I have left is automation API. The demo I showed you before was using our CLI, so Pulumi CLI. You have to go to PowerShell or other CLI and run our command Pulumi. What you can do instead is to drive the complete deployment from your C# program, like in this case. So this code speaks to the case that I just described, where you have a platform team and two applications team that build on top of it. So it has 3 stacks. One is a platform stack and 2 application stacks. And this program defines just a collection of steps of deployment. Like I want to deploy these 3 steps in sequence. And then there is just a for each loop, which says if it's not a destroy operation, just go ahead and for every step in this array, just go ahead and up this command. So the way you drive this is you just go to this command line, you type .NET run, you execute this program. There is no CLI anywhere. You can do it from your CI/CD system. You can write a web service which will do this on request, like provision a new database per new customer of your product. You can be as creative as you want and just drive the whole deployment from your IDE, but still be in full control and use all the benefits of the desired state configuration. Just to quickly show you how this execution looks like. I don't have time to actually run it. Maybe I can run it. but not wait until it finishes. So I just type, make it bigger again. I'll just type .NET Run in this folder where I'm in the Automation API folder, and it runs the .NET application that I have, and it starts deploying my platform stack first. Then it will go ahead and deploy applications after this is done. And you can control the output. This is just some default output. You can do like a Windows application that shows some progress if you want, and so on and so forth. It's just your imagination that is the limit here and your requirements. So with that, thank you very much for listening. Pulumi is open source and free to use. You can learn more about Pulumi at pulumi.com/Azure, and I'm happy to answer any questions if you have some. Thank you.
Wow, awesome. Thank you very much. Wow. So I think we had a couple of questions, but I'm going to be greedy and just ask my own question because this was all very interesting to me. So it's a three-part question. So if you imagine I'm new to Infra as code and I'm new to cloud native databases or services, and I'm looking at this and my head's kind of exploding right now because I'm thinking I'm used to older tools like Ansible maybe, or maybe I've manually provisioned environments or whatever. What would be the number one reason that you would give them to say you need to make this paradigm shift to doing this? That's part one. Part two would be, is it any easier, or what makes it easier to use services like Cosmos DB with these approaches if it is easier? And then the last thing would be any pitfalls that you would say watch out for when you're using this approach that you might not expect from what you've been used to in the past.
Well, to the first part, you need to separate learning the infrastructure itself, like learning what Kubernetes is and what kind of object you need to deploy there, and like all the Azure services that you need, from learning the tool. And my point is that you sort of cannot avoid learning the infrastructure in your company. Somebody has to have this knowledge, but then you don't have to make everyone learn that. You can also just, as I described, have some people specialized on nitty-gritty details of those services, and then they can explain to others and provide abstractions to others so that they wouldn't have to be Kubernetes experts in order to be able to deploy their hello world with code. And because application developers will feel very familiar with the tools and like the code and the C# and so on, they will be more willing to actually jump ahead and like start using this, in my opinion. So the Cosmos DB is great. I tried to illustrate this by using MongoDB API specifically, because like you get all the upsides of like the whole ecosystem built around MongoDB. When somebody built that Helm chart, like they didn't know I'm going to use it with Cosmos DB 5 years down the road. But you still get all the benefits of very flexible cloud environments where you are operating in. So you can create Cosmos DB for your, let's say you open a new PR for your system, you create a new environment with this tool, like you run your tests, you tear it down, you pay maybe 5 cents, I don't know how much, but you don't pay anything basically. And you still got the MongoDB, which can be comparable to your production environment if you want to. So you get like the full power of cloud and the full power of third-party tooling or like community tooling that you get. And the third question was the pitfalls, I guess. Yeah, I guess the first part is like the main pitfall is that you need to get through the initial barrier of like being not too overwhelmed with all the fancy words that I throw in my presentation, and this is like 1% of all the things that exist out there. So I think like putting folks into a more familiar environment is helpful, but of course that's a learning curve that everybody has to take through, and like they shouldn't take it too lightly.
Cool.
One question that we got that's probably just worth mentioning for everyone viewing is, what is the best way to get started if you want, if you're completely new to infrastructure as code and you just want to get started from scratch?
So on my last slide, there was a link, polumi.com/Azure. From there, you can get to like a getting started guide. From there, you just deploy a very simple, like not that involved application that actually a very simple storage account with a static website or something. And from there, you can get started. After you complete that tutorial and you already feel the workflow of how you provision new environment, how you make changes, how you destroy, since you can already jump ahead to like more advanced scenarios based on your interests, like Cosmos DB, Azure Functions, AKS, whatever.
Great. See, we're at time here, but thank you so much for your session. And
thank you, my pleasure.
Yeah, thanks, Mikhail.
Next up, I'd like to introduce Luis Beltran, and he's going to be talking about how to essentially set yourself free from your servers and what it takes to set up a serverless environment capable of performing CRUD operations on a Cosmos DB account. So really excited to hear this talk, Luis.
Hello, Gal. Good morning, good afternoon, everyone, depending where you are joining us. I hope that you are enjoying the Azure Cosmos DB Conf. So let's get started. So my name is Luis. I am a Microsoft MVP in AI and developer technologies. I am based in Czech Republic. I am currently pursuing my PhD at Tomás Bata University in Zlín. I am also lecturer at Tecnológico Nacional de México in Celaya, and along with some friends, we lead the community, Xamarin community in Spanish. You can find us on Facebook, and also Aprendiendo Azure, Learning Azure. Here you have my contact details in case you would be interested in talking about these topics. So let's get started. You have been learning a lot about Azure Function, about Cosmos DB. So I will go directly to Azure Functions. This is the classic model or hosting models that we have learned about the cloud. There are, if you have your on-premise environment, as long as you are going into infrastructure as a service, platform as a service, or software as a service, you are freeing up yourself with the responsibilities. So in software as a service, for instance, you don't have any responsibility. You just need maybe just a browser to start using an application such as Office 365 documents and so on. And if you provision some of these resources, for instance, a virtual machine, well, you are in infrastructure as a service, so you don't worry about the virtualization technologies. You won't worry about servers. You just go for the rest. You set up the operating system, the runtime, the data, your applications, and so on. So there is another model, which is serverless. And serverless basically means that you don't, you want to write code, you want to write applications, but you don't want to worry about provisioning a virtual machine or resources. So the cloud, Azure, will do that for you. So in this case, in this scenario, serverless, yes, you just worry, you just manage your functions, your code. The rest is already set up for you. And you can use your function, or you can integrate them in the other hosting models, even on premises, and of course infrastructure as a service and platform as a service. So Azure Functions basically works with events. You will write some code, and this code will trigger on when some events happen. So maybe you send an HTTP request. Maybe you want to execute some code according to some schedule every hour, every 10 hours, and so on. Maybe when your users upload a picture into blob storage, you want to execute some code for analysis or something else. So, okay, you set up an event, or you know about an event. Then you write your code. You have different options. You can write your code in C#, in Node.js, F#, and other languages. And what's one of the good advantages is that you can bind some input and output elements. So you can directly connect, for instance, to Cosmos DB, which is the main topic of today's session. You can also connect to blob storage service, table storage, or even you can send email to after some processing. So your code plus events is Azure Functions, basically. Well, as we have mentioned, yes, there is full integration with Azure services. So basically, Event Grid will here will listen will react to some events that are happening. So, for instance, in databases in Cosmos DB, when one of the items, the documents are modified, well, you can also catch that event. You can also integrate with other products such as cognitive services, stream analytics. It is actually a good idea to use Azure Functions and integrate it with IoT solutions. And also, well, if you don't want to write code, there is also logic apps, which allows you to design workflows, what process will follow after some, let's say, events or after some interactions. And well, yes, there are several triggers. I mentioned a few of them. So HTTP trigger is when you send a request over HTTP, like, okay, post, put, or even get. There is also a timer. So you set up a cron, let's say a cron statement, and then it will execute every hour, every Monday at 7 a.m., every day 5th of every month. Yeah, you can set up that. So you run your code when the specified events happen. So this is the example. Maybe you have a mobile application. You take a photo, the users take a photo, they send it to the cloud. And it is stored in blob storage, for instance, and maybe you would like to create different versions of this picture. Maybe you want to create escalated versions, resize them. So in this case, you can automate this task by setting up an Azure function with an input, let's say, element, which is the blob storage, and also an output, because you want to create some files and store them maybe in a different container. Okay, so and actually, if you are wondering, okay, is this code hard? Is this code complicated? Well, the truth is that no, and this is because of the bindings. Because, well, you have your code. For instance, this is C# code. There is a CSX file, and you have your bindings. Your bindings are set. You have a designer. You can do it graphically. You can select and connect by using, let's say, a connection string or a parameter. But this information is stored in a function.json file. So you see that we have an image binding. It's an input. You see the direction. The second one is output direction. So this one is output binding. Then you have the path. Of course, the connection tells you, okay, I am using this blob storage element. Storage account. And in the storage account, there is a container. The container is card-input. And then the file name. This is the file that the user just uploaded. So these two elements, such as the name and the path, can be used as parameters of my function. So the byte image, of course, means the element that just came in, that was just inserted. And the string file name, of course, refers to the name of this blob. Then you have the same for the output parameter. Maybe I have output blob. Okay, that's the reference. That's the string where I want to save the file, and I want to use maybe the same file name, but as you can see, in different container. They both use the same connection, and you can see the code is quite simple, just a few lines of code. You don't have to create like a client for connecting to your input blob storage and for the output blob storage. It's quite easy thanks to the bindings and the code, of course. What tools can you use to write Azure Functions? Well, you can even do it in the portal, as that's the case that I'm going to demonstrate today. But you can also use Visual Studio, VS Code, the CLI, and some other deployment options. Actually, if you remember, in previous slide, we talked about the on-premises hosting model. You can have your serverless functions running in on-premises environment, so you don't even need to deploy them to the cloud. They can work, and you can even deploy them to containers. So what happens with Cosmos DB and Azure Functions? Well, with the native integration between Azure Cosmos DB and Azure Functions, there are different ways to interact between them. There are 3 ways: database triggers, input bindings, and output bindings, directly from your Azure Cosmos DB account. So this means that you can deploy, you can create serverless applications that are based or rely on events with low latency access to rich data for global user base. Yeah, basically Azure Cosmos DB. So yeah, there are 3 ways. The first one is you can create an Azure Functions triggers, which is event-driven, which relies on the change feed streams to monitor your container for changes. So when there are some changes made to the container, this change feed stream is sent to the trigger and thus invoking the Azure function. Actually, there is also another nice talk in this Cosmos DB Conf by Gabriela Martinez. She talked about the change feed, so I recommend you to watch that presentation. The second one is prepare the input binding. So you set up the connection for your Azure Cosmos DB, and you can use this element, you will see, with very few lines of code and retrieve the data that you have in your Cosmos DB. And yeah, that would be the input binding. It will read data from the container when the function executes. And the third case is bind a function to an Azure Cosmos container with the output binding. You will use this when you want to write data, for instance, when you want to insert a new element. Okay, so let's go for the demo. And just give me a second, please. I will bring my, yes, I will bring here my, I have already set up a Cosmos DB database, so an account. So you can see in this case, I have 3 members. Yes, I have this informatics management. Okay, yes, this. I have these 3 elements. So I would like to check the code. Okay, give me, maybe I will set this a bit larger. Sorry about that. Yes. So we have our resource group, and I have already set up some Azure functions, which is here, university functions. So if I go to my functions, I will have this, for instance, these get students. All of them are HTTP triggers. And well, I first want you to look at the integration before looking at the code. So in this integration, I can easily add input or output bindings. In this case, it's a get a student, so I want to read information from my database. So you can add an input, and when you add the input, you pick from the list. You have, as you can see, well, I cannot modify it, of course, but you have a blob trigger, you have Azure Cosmos DB. Then you set up some document parameter name. This, you will use it in your code. In this, my case, it's input document. That's the reference for the parameter. The database name is studentsDB. My collection name is students. And this is my connection that I created for my Cosmos DB. If I don't have it at the beginning, of course, I can create it, and it will detect. In this case, I have the Cosmos DB account in the same resource group. And I can set up document ID if I want to, and my partition key, which is optional, but it's nice to set it up from the beginning. So it's faculty. And that's it. Then look at the code, and it's quite simple. Well, first, I just need to, well, you don't need actually all these, all the namespaces, but I added them, but you don't need them. I just set my, let's say, my class student, which with the properties. And then you can see in the parameter, I just have the input document, which I mentioned earlier. I set this one as a list or enumerable of students. Then the code is quite simple. Convert maybe your input document into a list of students, and you can return it. That's it. Then we can test it. Azure Function provides a nice console to prepare a request, get, post. You can also use other tools such as Postman if you want. And that's it. I don't need to bring any parameter. I can leave it. So I will run this. And we will get the information here. So yeah, so you see, this is my data. It's already in very nice JSON style. So yeah, I have brought all my information from my database. That's it. Then you might wonder, okay, okay, so this is nice, it's in the portal, but how can I connect it to my application? Well, Azure Functions. In this case, since it is an HTTP trigger, it means that it will only execute when I send a request. So there is get function URL. And in this case, I have this URL. I can maybe integrate it in my application, or I can check it in the browser, and you will see the data. So yeah, that's just it. It's the same. So yeah, now you know how to integrate it. What about some other operations? Well, in this case, I have also prepared add a student, which is this one. So it's more or less the same. In this case, I want to actually write information. So the first thing is, okay, I create my function. Then I go to integration. And in integration, I don't want input trigger. Now I want output. Sorry, not input binding, output binding. And you see that in this case, the output I have already set up an Azure Cosmos DB output document. And let's just briefly explore it. It's basically the same, but now it's an output element. So here we have the binding type, of course. This is the reference that I will use as parameter in my code. And the rest, you know it. Database name, collection name. I don't want to create the database. It already exists. And my connection and my partition key. That's it. Then the code, yeah, it's also simple. You will see. So, okay, yeah, the same. I have my class, and here I have the reference, my output document. It's an out parameter. Then, in this case, I need to provide the information. I need to send a post request with the information, yes, that I want to insert. Then so I get the body, I convert it, yes, I deserialize it, yes, and then I set the value for output document, new, and then I provide a bit of information that I will get from my post request, and that's it. As soon as you set up this and, of course, finish your code, it will be written to the Cosmos DB. So we can test it. So for this, I have already this value. Okay, I will change it. Let me put some other information. So faculty is technology. And let's go for, I don't know, some errors. So let's run it. Okay. Okay, so the response is 200. Yes, well, in this case, I didn't set a block. I just get a response. But I can go back here to my get students. And now I have 4 data. I have new elements. Okay. So, yeah. Then for update and delete, well, I have an issue there. So I will not show this. Well, it should work, but for some reason I am getting some error in delete, but I can share this later in my GitHub repository. But yeah, it should be also, I see it's just some minor detail there. But of course, the idea here is that you create this very easily. As you can see, the code is quite short. You just you can set up in minutes. And well, yeah, also the same goes for this add student. There is also a function URL, which I have, well, okay, I clicked, but I shouldn't have. So yeah, just a second. I get different function URL. But of course, I cannot test this one directly here because I need to bring some information in the body, for instance. Okay, so but yeah, so that's why this one will not directly work here. So yeah, essentially that will be all. Yes, as I said, well, I will complete that part, the update and the delete, which is giving me some issue, but I will fix it. So the call to action, I share this couple of links. You can take a screenshot, or I can share the presentation later as well. There is serverless database computing with Azure Cosmos DB and Azure Functions. There is this link, and also the video that I referenced a bit earlier by Gabriela Martinez for the Azure Cosmos DB Conf, integrating Azure Cosmos DB with Azure Functions. So that will be all from me. Thank you very much for having me. Please, if you have any questions, I will do my best to answer them. Here you also have my contact details. So yeah, I'm up for questions. Back to you guys. Thank you.
Great. Thank you so much, Luis, for a great presentation. You made it really clear how the complementary benefits of using Azure Cosmos DB and functions work together to really build powerful applications. That was really cool. One question we got in the chat was around performance. And what recommendations do you have for users who want to really leverage functions and Cosmos DB in terms of performance?
Yes, that's a good question. Thank you. Well, it is true that serverless has some requirements. Like, for instance, if your application does or your function doesn't get a request after 10 minutes, it goes, let's say, back to sleep. So next time that you bring it up, that you send another request, it will take some time to wake up and to execute your code. I have a small trick for that. I always keep the let's say the server running or the virtual machine running where the code is host. I also set a timer trigger that is executing every 9 minutes. So my server is always running. You might wonder, okay, but is this going to be a costly solution? Well, the truth is that Azure Functions has a micro billing, let's say, feature, which means that you only get billed by the time that your code is running. I mean, executed. Even if your code is always hosted there, you don't get billed as it would be for a virtual machine or for an app service. So, and the cost is you can get maybe even less than $1 per month. So I think I have got good results. I mean, regarding performance. You can also create Azure Functions instead of serverless. You can set it as an app service if you find that it's let's say slower or something. But so far I don't have encountered any issues. I think it's a effective way to connect to your database with cross operations.
Great. So if I'm understanding correctly, it sounds like we're keeping the connection live so that you're always getting the most throughput possible.
Yeah.
Awesome.
Yes, exactly. Yes.
I have some more questions, unless Theo or Stephanie, if you have any other questions, I can follow up with some more.
No, go for it.
Cool. So one question that I actually personally was wondering what are the best examples that you would say for each of the three cases that you mentioned around measuring changes, input bindings, and output as well? Like what examples have you seen in the wild in terms of using that?
Yes. For instance, well, I have created a bot that is running in actually in let's say some channel. It's YouTube actually, and the idea there is that the users send a request and they let's say request music like, okay, this streaming plays some music. The user wants to listen to some song. So it actually uses Azure Functions. I have a bot, and this bot calls these functions. The information is saved into a table API. It uses the table API of Cosmos DB and gets the information. Okay, this is your song. It will play next. I store it in a queue. Actually, I use a queue for that. So yeah, that's one example that I have been working on. I have also seen integrations with IoT solutions. So in this case, IoT devices generate a lot of information every second, every short period of time. So, and you might have distributed your devices in different regions, in different countries. So you can also send the information to the IoT hub and then process it with the Azure Functions. Analyze your data, then store it in Cosmos DB, for instance. So yeah, that's another scenario that I have seen regarding this. Yeah.
That's really cool. Is this music app something you're planning on releasing, or is this just a side project for your?
It's a project for a friend. Actually, it is already running live. I can share the link later if you would be interested. It's actually for fun. I made it for fun. I was let's say I was a fan of this chat. I was interested. Okay, can I do it better? Can I learn? Actually, I learned a lot about functions, about integration with technologies by doing this. It was just by fun, and yeah, I think that's where you can get the most about technology. So yeah, it's already live actually. I will share the link with it.
That's a really great point. I feel like combining something you're passionate about something you want to learn more about, really allows you to learn and have fun while you're doing it. And obviously, we love when that involves Azure Cosmos DB, so I'm definitely going to mention that. But yeah, anyways, that's really cool, and it was really interesting to learn about Azure Functions. So thank you so much for going through all of that and showing us more about that.
Yeah.
Thank you for having me.
Thank you, Lewis. Awesome. It was a great session on functions and how to use them with Cosmos DB. So it looks like we're on time. So thank you again, Lewis. So now for the next session, we have Pascal Desmarais, who's going to do an awesome session on data modeling and schema design for Cosmos DB. Take it away, Pascal.
Thank you, Theo. Hello, everyone, and welcome from Brussels, Belgium, for this session of the Cosmos DB conference. So let's say that you're new to Cosmos DB, but you already understand all of the great things that it can bring you with high availability, high throughput, global distribution. Now you decide that it's time to give it a try. You go to the Azure console, you create a Cosmos DB instance, you select the resource group, and then create an account name. And then you get to this third question. Choose the API and data model to use with this account, along with a drop-down with 5 possible options. So which one do you choose? Why does it say core SQL? I thought this was a NoSQL database. So in this session, we will attempt to clarify why the choice of this question is critical and how to choose the best option to suit your needs. So let me introduce myself. I'm Pascal Desmarais, founder and CEO of Accolade. We produce a data modeling software for NoSQL databases in general and Cosmos DB in particular. We developed what may look like a traditional entity relationship diagram modeling tool, except that it was specifically designed to handle the things that the traditional tools could not handle. And that is the complex structures found in modern big data, and also property graph databases like the Gremlin API enables. So NoSQL databases are usually divided in 4 families, and Cosmos DB supports all of these different flavors. JSON document stores, with that are supported with 2 different APIs, the SQL-like API called Core, and also the MongoDB API. And a key value store with the table API, the property graph database accessed via the Gremlin API, and the Cassandra API for column families. Cosmos DB is unique in allowing something that was labeled polyglot persistence by Martin Fowler back in 2012. He said that instead of just picking a relational database because everybody does, we need to understand the nature of the data that we're storing and how we want to manipulate it. The result is that most organizations will have a mix of data storage technologies for different circumstances. And that's critical because we need to realize that applications quickly become very complex. And it would be an illusion to think that there is a single storage model that fits all purposes. So choosing the best tool for each use case ensures that you don't have to make endless compromises and that you can leverage the strength of each storage model. So if we take an example of an e-commerce platform, for example, we can see that each section of the user experience and processing is actually very different. While your master data may be stored in a relational database like Azure SQL, you may want to use the Cosmos DB table API to store very quickly and be able to retrieve shopping cart and session data. Then completed orders as well as serving the product catalog for shoppers would be best served by the Cosmos DB JSON document APIs, either the SQL API or the MongoDB API. Logs data, on the other hand, on which you may be doing aggregation for specific columns, would be best served through the Cassandra API. And then you've got fraud detection during checkout, or you may have a recommendation engine. And that's where a property graph database will shine. And so the Gremlin API will be best for that use case. And then finally, you might have an analytics store for data self-service. And for that, Azure Synapse would be your ideal tool to serve this use case. There's other examples of where polyglot persistence is in place. And for example, a data pipeline from transactional databases through analytics and self-service data democratization. So, but this takes us off the subject of Cosmos DB, but it goes to show how polyglot persistence is a reality, and we need to use the right tool for the job. So, in this table, which is a bit of a caricature, we have a comparison of all of these technologies, and what makes one better to the other, better than the other on specific use cases. But it goes to show also how one technology cannot fit all and is not, in absolute terms, better than the other technologies. And so we see here, as we saw in the example earlier, that relational best fits use cases of master data and transactions. It has the benefits of being well known by many people and enforcing the schema at the engine level. But it comes with problems such as the fact that schemas are hard to change and the technology does not scale well or horizontally. So key value stores are great for caching. And so incredibly fast performance for reads and writes. But if you're doing queries on anything else than the key, it's going to be really difficult, if not impossible. That's not what it was done for, but as we could see, there's specific use cases where it shines. Document databases, on the other hand, are extremely flexible, still very performant in terms of access speed. It allows or even encourages data duplication, which some might see as a challenge. Its high flexibility presents the risk that people might use it as a dumping ground. So you need to be watching for that. Columnar databases, served by the Cassandra API, is really great for sparse data, and it has very fast column operations. But it's really not ideal if your data is not immutable. Graph databases are, a separate family. It's great for finding hidden relationships that you didn't know existed when you did your design, but that you can figure out through traversal of the graph through your queries. But it can be a bit difficult to model. And data warehouse like Synapse help you slice and dice the data for analytics. But of course, it's not for transactional use cases. So transitioning to the challenges when doing data modeling and schema design for Cosmos DB. You may have heard people say that with schema-less databases, you don't need to care about the schema. They also call this a schema on read. meaning that the schema does not need to be declared ahead of time and can be figured out when you read the data. But these terms can be misleading because, in effect, when you persist data, it automatically has a schema, it has a structure inherent to the fact that you just stored it. So we prefer to talk about dynamic schema evolution, particularly in an agile environment when customers' needs evolve constantly and at an increasingly fast pace. So be careful not to confuse flexibility with sloppiness. And don't take this from me. Gartner has been alerting customers not to fall into this trap and approach this with sober awareness to the fact that schema on read does not mean schema by amateurs. So when doing the design for a schema on read or schema-less database, it's really critical to forget what we've learned for decades with relational databases. The rules of normalizations have taught us to design data models in an application-agnostic manner, making sure to have this beautiful generic design with no duplication of data. When it comes to NoSQL databases, we need to get rid of all this baggage. We need to turn the rules upside down based on the requirements and the design of the application. We need to identify and analyze the access patterns, the actual queries needed to access the data, whether it's for screen display or reports or or downstream processing. These access patterns are critical so we can design the data model in a way to satisfy these queries in the most efficient manner, which is by avoiding joins that inevitably slow down performance. And that will dictate how we store the data. Okay, so we will first figure out how we will read the data before we figure out how we store the data. So I strongly suggest that one should never write a line of code without truly understanding the design of the application and hence the data model. And then in an agile manner, you can iterate on this flexible schema and the application that leverages it. And that's the really agile way of doing things right. So a data model is the blueprint for applications. You would not imagine building a house without a blueprint for the architect and contractor to interact and communicate, correct? A data model allows two things. It allows for the architect to rigorously think through all of the details of his originally sketchy vision. And as a communication tool, it helps discuss his vision with the owner on one hand to make sure that we all agree on the vision, and also with the building contractors and the builders to make sure that they will execute on that vision properly. So while you might not need an architectural blueprint to build a shack in the backyard, you will definitely need one to build a house or skyscraper. If you want to avoid huge technical debt, you'd better think things through before you write a line of code. So yesterday in the conference, there was a fantastic session by Lenny Lobel on this important subject of data modeling and partitioning for Cosmos DB. You may get the video on demand, and I'm not going to repeat here what was said during the session. The session was mainly on document stores with the Core SQL API or MongoDB API, but I'll reinforce the message and talk also about the Gremlin API. The beauty of NoSQL databases is the ability of avoiding the costly joins when reading data, which brings a much higher performance, of course, if you avoid the joins. How is this achieved? Actually, you're doing joins, but you're doing the joins when you write the data. And that makes it so when you read the data, access is incredibly fast. So that sounds great, but it should be done carefully with the full understanding of the cardinality of the relationships, of the data you're suddenly now embedding together. So, for example, you wouldn't want to have such a high cardinality that the document would grow out of hand. So, for example, if you had a social network and you have 1 million followers, you don't want to put the 1 million followers in the same document because this document would grow out of hand. So referencing is still a possibility with NoSQL and obviously with Cosmos DB, and it should be used where applicable. The only difference is you cannot count on the database engine to enforce these relationships, and so you need to build that in your application. So aside from the important restriction of the cardinality, you should do embedding when in doubt. Favor embedding when in doubt. The reason is that you can store together information that belongs together. So it makes a lot of sense, not only for humans, that all of this information that belongs together is put together, but also for the systems, because they only need to access the information in one place instead of gathering information from all different places when doing joins. So if we take the starting point of Lenny's session yesterday, and we put it into an entity relationship diagram with nicely normalized flat structures, as we would store traditionally in a relational database, we would get this ERD that we're all familiar with. And through a process of importing the DDL of that structure, applying the principles of denormalization, as we've seen, to embed data based on the analysis of the access patterns and queries, we come up with a schema design that is optimized for Cosmos DB. We can iterate on the structure after discussing with the various stakeholders of the application, making sure that we achieve the expected objectives. Then we create a series of artifacts, including documentation, schemas, and even REST APIs. And we end up with this kind of data model where you can see how here on the left, customer addresses have been embedded into the customer document along with password information. On the sales order side, we see how the order details info has been embedded as an array of subdocuments, and et cetera, et cetera. And we've gone from 9 tables in the original in the original model relational to just 3 containers here. They're separate containers because the partition key was chosen to be different for efficiency purposes and to ensure the balance in the data loads, both for storage and retrieval. If for some reason the choice of partition key had been different, you may have you may be able to mix up physical documents into different logical containers. But so you have all kinds of flexible approaches that can be evaluated based on your use case, and particularly based on your access patterns. So now let's switch to a property graph example, which was not covered in yesterday's session. So here's an example of a property graph that would be used, leveraged using the Gremlin API. So for the example, theoretical example, we have a ring of fraudsters that share, a subset of legitimate contact information that's been verified by financial institutions, and like, for example, phone numbers and addresses. And the ringleaders open accounts using these synthetic identities. And create new accounts, for credit cards and unsecured credit lines, overdraft protection, et cetera, et cetera. So if we model this using Accolade, for example, for the purpose of creating a structure to be used by the Gremlin API, we're going to create a node or vertex, these circles here in the diagram, for each concept in the example. Then we create relationships, which are sometimes called edges, between the nodes. Both the nodes and the edges can be enriched with properties. So that's a special feature of property graph databases. The relationships and the nodes have their own properties. And this allows you to create queries that traverse the graph to reveal connections that you didn't know existed. And that's what, for example, will reveal that phone numbers, presumably legitimate phone numbers and addresses or bank accounts have been shared by different people, and that's what would reveal the fact that we should suspect a fraud in this instance. And you could forward engineer the structure to the Cosmos DB instance, and then start loading your graph in Cosmos DB and start doing your queries that will reveal these relationships you didn't know existed. Okay, so we're almost out of time. As you can see, while NoSQL seems easy at first, it actually requires deeper skills to truly leverage the capabilities of the technology. This translates into high performance for your application, greater developer productivity, and lower cost of ownership. So just to repeat myself a little bit, storing data correctly in Cosmos DB and leveraging its capabilities will achieve to achieve these objectives we just saw requires a complete mind shift. You need to unlearn what you've known all along with relational databases and embrace this new approach of analyzing your access patterns and queries before you can structure the storage of your information following a data model that will continue to evolve with your application as it grows in feature set, and that will dictate how data is stored in Cosmos DB. You should pick the right tool for each use case, and of course, Cosmos DB offers you that choice of the right tool for the right job. And if it doesn't, you still have the rest of the Azure offering. So thank you for your attention. We can now go to Q&A. Back to you guys.
Awesome. Thank you, Pascal. That was really great. I really loved, in particular, your very simple kind of characterization of the difference between the app dev journey for relational and NoSQL, it being kind of, an app dev centric data model process. In fact, I wonder if with the producer's help, we can maybe get that slide up again. I really love that simple slide, or maybe not. Yes or no? Yeah, the last but one slide, I think it was.
This one?
No, the one before that. Yeah, this one. Awesome. Yeah. So it's just that really spells it out for me. I guess my question is, it follows from this that there are going to be things that emerge for NoSQL databases like Cosmos DB that are good practices that would have been or would be anti-patterns in relational databases, and vice versa. Things that are, let's say, anti-patterns but would be perhaps a good practice in a relational database. I wondered if you wanted to, not to put you on the spot, if you wanted to call out maybe a couple of those that you've seen in the wild where people have fallen into the trap of either not doing something that they should do because they thought that was an anti-pattern, or doing something that they thought was good where they've come from, but it turns out to get them into difficulty.
Yeah, so excellent question. So, the flexibility and the power of JSON is something both wonderful and dangerous at the same time. So it's wonderful because it describes the schema, which serves the schema on read approach. And it's also incredibly flexible. It can be polymorphic, as we call it. So you could have one document or one version of the information which is in one form, and then the schema evolves and you have the coexistence of another set of information for the same concept that follows a different form. And this polymorphism is wonderful because it's flexible. It helps you evolve very quickly, but it can be dangerous if you don't do it with rigor. It can lead to chaos if you're not organized. And so many people think in the beginning that you can let that grow organically. And then they realize that maybe there are other applications accessing the same information, and that means that each of the applications needs to be enhanced to understand the different forms that the data might take in your document store. And so, data migration may be best advised to be performed because you don't want to let this grow out of hand. The advantage is that you can do this data migration at your leisure whenever needed, instead of being forced to do it when you do a schema change like you would in a relational database. So that's one example of dangers that might come up with this flexibility. The other one I mentioned already in one of the slides is the risk of these documents becoming dumping grounds. I have seen ridiculously big documents, documents that may be megabytes of information, and given the performance, the costing model, et cetera, this is not advised. It should remain pragmatic, and the documents should not grow out of hand. So I would warn people against these traps that are really allowed by the flexibility of JSON and by the fact that you don't have the rules of normalizations that are sort of guardrails to help you. So be careful about this flexibility getting out of hand.
It's a great answer. With great responsibility comes, with great power comes great responsibility, right?
Exactly.
Yeah. Anyone else have questions?
We did get a question from our viewers. If you can quickly explain the schema in the context of transactional store.
Yeah, so obviously transactions are well served by relational databases. When it comes to NoSQL databases, these transactions need to be built in the application because the engine does not enforce the transaction. This comes to the concept of also eventual consistency, which I did not talk about, which some of the old school people, have a problem with, that NoSQL databases allow eventual consistency. I think in these terms that perfect transactional consistency is only possible when you own the full chain of the transaction, which is easy within your own database, but when you're transferring money from one bank to another bank, it doesn't happen. So get used to the fact that eventual consistency is just a very efficient way of doing things, and and you should build in your application the checks and balances to make sure that nothing goes up in smoke.
All right, thank you so much, Pascal. Up next, we have a quick video on throughput and pricing. So for a long time, Cosmos DB had only one way of provisioning throughput, and then customers would have to really know their workload very well if they wanted to effectively and efficiently provision that throughput. And so we realized that customers are different, and we all have different needs. So we've been working hard to create new ways for customers to provision throughput, including with autoscaled and serverless. So watch this quick video to explain the differences between the two.
Azure Cosmos DB helps you get more value for your money by making it easy to manage the components you pay for, database operations, and storage. The cost to perform database operations, including memory, CPU, and IOPS, is normalized and expressed as a request unit. More request units are charged for more demanding activities. For database operations, you can select one of two models, provisioned throughput or serverless consumption. Provisioned throughput is the capacity you allocate for database operations, measured in the number of request units per second and billed hourly. It works best for workloads that always have some traffic and require high-performance SLAs. If the traffic is predictable, you can use standard provisioned throughput to manually set and adjust capacity as needed. If the traffic is unpredictable, you can use autoscale provision throughput to instantaneously and automatically adjust capacity between 10 and 100% of your set limit. Autoscale becomes more cost-effective than standard when traffic is unpredictable and not close to maximum capacity most of the time. Provision throughput may not suit workloads with only occasional database operations and lower performance requirements. These applications can benefit from the serverless model. While it has a higher unit cost, it's consumption-based and only charges for the request units used per database operation. With consumed storage, fees are charged for the total gigabytes used per month for both transactional and analytical storage. You also pay for storage I/O and analytical storage. Get the most value from your workloads by understanding the components you're built for in Azure Cosmos DB.
All right, so these are definitely great offerings that we have. Make sure to definitely take a look. So up next, we have Stefan Wiggers. He's a cloud architect, and he is speaking on cloud solutions with Cosmos DB.
Hi, everyone. I hope you're enjoying the Azure Cosmos DB Conf for now, and there were some great sessions. I will continue with my story on integrating Azure Cosmos DB in your cloud solution. So I'm Stefan Wiggers, Technical Integration Architect at HSO. little bit about myself. I'm an Azure MVP. I started out in the integration space, and since 2015, I'm now in the Azure SKU with the program. I write for InfoQ, so this is an international website about all kinds of technologies, including cloud technologies like AWS, Azure, Google Cloud Platform. Also organizer of some of the events that are listed here, user groups, where sometimes also Cosmos DB is one of the topics. And besides that, I like running, so hopefully when the global pandemic will go away, I'm able to continue my marathon running. Okay, so what I'm going to do is kind of tell my Cosmos DB story from my view, with some experience I had with this serverless or this capability in Azure. Also, some use cases where, I was integrating Azure Cosmos DB with search, leveraging your change feed capability, and also some integration with other Azure services. So initially, when Cosmos DB came to place, so this is a little bit, I also like to know a little bit about the background of the service. This was a couple of years ago. Nima Ramya, just SQL Pass, introduced the fact that, hey, there's a need because the global increase of data that kind of need what's called an earthly database, kind of give your scalability and consistency everywhere in the world. So kind of a project started, which was called Project Florence by Dharma Shukla, which kind of, something with these trends and creating a database, it became Azure Cosmos DB. Around the time in 2017, the service was being announced, and I was trying to get a little bit more familiar with the service. I was working for a customer that was looking, for instance, into the graph model, and I think this has already been explained in previous sessions. So you have like your nodes or vertices, and you have your edges. So the combination with like someone knows someone else, someone uses a certain device, as you can see depicted in this picture. It's the underpinning kind of model you also find in LinkedIn and Facebook. So I was getting in familiar with side because of a project I was working for. So this was kind of a knowledge base for tax returns. So this was done by ReBusiness, part of the Relics group. So tax returns for the Dutch tax. And they already had this old knowledge base implementation. It was an IaaS solution on combination with Solar technology. That's kind of a search engine. And the company wanted to move forward. They wanted to embrace the cloud. They want to kind of use a cloud platform like Azure with the pay-as-you-go service, but also completely go platform as a service. Also to create this future-proof knowledge base to give a little bit more richer search experience for the customers. Because of the tax returns is kind of a subscription model. It's kind of what's called an almanac, enabling people to fill in, or small or medium businesses to fill in their tax returns in a way that, grosses them much money. So the functional components is, on one end, you have the content creation, which is a CMS system that flows in with jurisprudence, tax laws, etc., some leading comments explaining how you should interpret those tax laws, which comes then goes through what's called content constitution. So it's ingested, it's cleansed, it's subsequently pushed into a knowledge base where you have your content types and relations between them and index and all that stuff. So that's your knowledge base. So this is kind of the functional aspect. If we look at the building blocks, so we kind of set up this proof of architecture where we embraced some of the Azure components, including Cosmos DB. And some of the parts like the integrate, match, and merge was done through .NET or web jobs and functions to push one end the content, tax laws, jurisprudence, all these kind of content and content types into a document DB store, which was subsequently indexed, leveraging the integration with search. And on the other end, another part was being used, or at least you had the document model on one end, and you had the graph model on the other end to set the relationships between these content types. Also to, for instance, implement the type of hierarchy, maybe also some recommendation with regards to finding related content to the tax laws itself. And then these were exposed through content API, which was .NET APIs, functions, or other type of code exposed through web apps. So kind of the solution architecture in general is you have your CMS, so content management system output, which is the tax law, the jurisprudence, etc. The content itself being pushed into a document DB model as text with some characteristics and properties, indexed, and through endpoints enabled to a front end. Similarly, the metadata model around all these content types were pushed into a graph model, and then also being exposed through an API. And when the call was made to that graph model, the Gremlin API was being leveraged. So going forward, kind of what meant is that when someone looked up certain tax laws, there was an initial call to the indexed endpoints that sits on top of the document DB store, but subsequently another call was being done to also get the related content provisioned, or at least made available in the front end. This way giving a more richer experience that previously was not aware because of the relations between the content. And then subsequently, if you clicked on one of the related content, you wanted to drill now maybe more in a leading kind of comment or an explanatory how to interpret the law, then there was another call to the content itself. And this kind of led to a reference case because we kind of also, as a supplier for this solution, we're working closely together back then with Microsoft, with a former PM called Danny Lee, who helped us out in validating also our proof of architecture and see if this things we found out and these learnings to really push forward to an actual solution itself. And this is kind of what you can find back online as well. So going forward, so from my learnings of this project, I proceed on to another project. I'm usually doing integrations between the systems on-prem, in the cloud, or doing complete cloud-native integrations. But for a food distributor, we build up a solution where financial and operational data was being pushed into Dynamics 365 Finance and Operations, which is currently now Finance and Supply Chain Management, still the same Dynamics system, but a different naming. And we pushed some of that data that's being mapped a bit into, or at least pushed it to a logic app, which sits as a barrier between those systems, and then pushed the payload to what's called a recurring job. There were no business event implementations back then, so the ID coming back from recurring job was pushed at least to another logic app that would just get the status of that recurring job and if it's finalized or not. So this is kind of a hybrid solution where end-to-end monitoring is being put in place, where we leverage Cosmos DB as well. So leverage all the metadata, the logging data centrally through a logic app into a Cosmos DB. So kind of what worked is all the logging was being pushed into a Cosmos DB instance using a logic app. It was indexed subsequently, similar to the learning app from our previous project. And then data could be shown through getting the data out of the Cosmos DB in combination with calling out Dynamics with the job ID or getting maybe some of the original mapped files from BizDoc server. So kind of this is how one of those functional logs will look like. So this is kind of one of the many loggings that were inside Cosmos DB, as you can show of the way it's structured, leading to the fact that you have this dashboard enabling the functional team that had to monitor the end-to-end process to look into the loggings of each of the process itself, enabling them to use some query capability as well. And drill down a little bit deeper into all of these steps, and these steps of course are all data harnessed as documents inside document DB and indexed, and then also getting access to the mapped files through a function. What we also created was kind of a functional alert, meaning that we also leverage the change feeds capability in Cosmos DB. So some of those events or loggings were information coming back from Dynamics indicating whether a job was filled or not. If a job was filled, so it's kind of an event sourcing looking at the state of each of these processes, was filled, process with an error or an error, meaning that we want to isolate the information, push it into a blob storage, leading to a blob created event, so leveraging event grid, getting all the metadata out and push that notification to the functional team. And this led to the fact that the functional team will get a URL as well, straight away directing them to what went wrong from the processing of the recurring job and providing some details as well, as you can see here. So to demonstrate a bit how this change feed capability works, I kind of set up a demo. So imagine you have your house instrumented with all kinds of sensor and devices, and you've registered those with a service called IoT Hub. The data subsequently is being streamed through event hubs to a function which pushes that data into a Cosmos DB, which is kind of set as an event source. Also, in this demo, at least what I'm going to do is I'm going to mimic it, the fact that every change of one of the temperature of the room is also a trigger for the function with regards to a change feed. So there's an additional function. If the temperature goes above a certain temperature, then a message is being pushed to a queue, which has a logic app as a listener, and then with logic apps, there's many connectors you can leverage also for notifications like Twilio, Exchange. So I can send out a notification to my phone or somewhere else saying, hey, it's too hot. So I will move to my little setup. So I just have a few of these entries of a few of the rooms. Let's say, imagine in my house. And I could, for instance, do an update. And this would lead to the fact that a function will inspect, at least get the trigger because of the change feed and its binding, will look at the actual temperature. And if the temperature is above 25 Celsius, it will lead to the trigger of a logic app. So if I move to my logic app, and I've already ran this before, the logic app gets triggered because it listens to the queue. It will get the document, the change document, in this case where the temperature has changed. So it's changed to 29.5 Celsius degrees, meaning that it went over the threshold of 25, leading to the push of a message to a queue, which led to the fact that this logic app is being triggered, and it uses the SendGrid adapter. So it's one of the many adapters allowing to send a message to my email account. And this is the message I get back and this shows me, hey, the temperature is hot. So this is kind of the signaling towards my phone in this case, or email. So in general, this is just a simple showcase of how the change is being leveraged. And if I revert back to what I was talking about before for this customer, all the inserts of the logging leads to all these change feeds where there's a function behind it, leveraging that Cosmos DB binding, and then push out notifications in case there's an error. And finally, there's also a way of leveraging logic apps with Cosmos DB in a way of ingesting data. So you can set up a simple pipeline when there's or simple data ingestion pipeline using logic apps when there's open exchange rate data, for instance, so this kind of currency data that you're going to ingest and push into a Cosmos DB. So this is kind of a setup. This is more a pet project, but it's derived from an actual use case at a customer where at an interval of a couple of hours, data had to be ingested, incorporated into a data store like a Cosmos DB to further processing and look into their way of providing services to their business. And the way this looks, and I will quickly go to my environment again. So this is kind of the setup completely. You see all kinds of Azure components, including a Cosmos DB, where all the currencies are being persisted. This will lead to an execution of a logic app. So this demo has been running for quite a while, and you can see kind of the output of the response from this open source exchange rate, which is being pushed into document store I have in my Cosmos DB, which is actually this one. And you see there's a lot of entries. I think this is one of the first. I've been running this sample for quite a bit since 2018. I think currently we're at 22,367 entries. So I'm going to use this data later on to do some analysis, maybe in signups or other. So I'm going to extend it again with some other integration with Cosmos DB, leading to more insights in how to leverage that data. So as you can see, you can integrate with many Azure kind of capabilities. Some are very interesting. I think search is one of the really valuable integrations with Cosmos DB, leading to quite some valuable value to the business with regards to your solution you're leveraging with Cosmos DB. I've noticed that in these cases with Read Business, but also with the whole Future Spirit, that Cosmos can be quite valuable and also a vital component in your solution architecture. What I also found out when I talked about some of these use cases, some of the people or developers like, yeah, but Cosmos DB is very expensive. And it's not the way you have to look like it. You have to look at the added value of Cosmos DB itself. With regards to the Relics group, they kind of had the subscription model, which grossed in a lot of money with regards to the subscriptions. And then based on the TCO, which was far less than the income, it wasn't so expensive. And with the whole view distributor, we had a TCO of our kind of monitoring solution in general, including we had the functional monitoring, which was less than 200 euros a month, but provided tremendous value for their operations and also the functional team behind Dynamics 365. So I'd like to thank you for attending this short but sweet session around integrating Azure Cosmos DB with your other Azure services. So back to you guys for some Q&A.
I think we're all stunned by your presentation.
Oh, really?
It was very good. Yeah, I'm interested in whether or not you see any kind of ranking order between what people prefer in these types of solutions, or particular approaches that people take when they're trying to make these composite architectures of cloud native services. There are popular patterns that you've seen yourself in the wild?
Yeah, it's definitely around what I talked about with regards to the event sourcing, enabling you to push documents into that store and then leveraging the change feeds, which unlocks many types of solutions you can do. In this case, it was just about operations, but it led to the fact that we could do targeted emailing towards the team that is, should get that information. Instead of generally having information or logging going to an IT department where, okay, what do I do now? Dynamics is broken. Oh, I don't know. Or dimension is missing. Or so, yeah, that's definitely one of the patterns I see a lot with regards to Cosmos DB. Other being storing data and leveraging search, which is a great combination, I must say.
Yeah. I guess one other question as well. We just had the cost optimization video flash up before, but I wondered if you had any tips or extra thoughts around how people can approach this. Was it, as you said, we have had this this outrageous accusation at times around the cost.
I know.
If you have any tips there.
Yeah, well, we did some performance testing. I think Mark Brown also created some really great code to do some optimizations and performance with regards to your Cosmos DB, determining what kind of RUs you need. Especially with these customers that I work with, we also very looked at cost and how to dimension, or at least how to set the RUs. We saw that the workloads with regards to that hybrid scenario wasn't that high, leading to, I would say, minimal costs. With regards to the setup for a knowledge base, we noticed that initially when you do your loads, you need to bump up the RUs, but then you slowly can decrease them because then all your content is in your data models, right? And then it depends more on the traffic. So you have to dynamically sometimes set your RUs depending if during business hours, for instance, there's more people going to let's say a knowledge base than in the night, right? So you have to look at those dimensions as well. So I think monitoring traffic, so we definitely looked at traffic, especially at the Relics group, we looked at traffic, so when can we expect more traffic and when can we expect less. And with the hybrid solution, it's just that we knew the numbers. We knew how many traffic there was going to be generated during the month. So there were a few operational data entries during the day, and with financial data, it was just once a month. So you know exactly when to expect. So you definitely have to look at traffic as well with regards to RUs and the usage and the workloads of your Cosmos DB.
Yeah, I think everybody should take note of your Twitter handle because they'll be asking you for tips. That's really great. Yeah, engaging with the cloud economy as well as understanding the different offers that we saw before in that video.
True.
Do we have any other questions out there?
Yeah, one question that came up was, do you ever find yourself using the different forms of provisioning models for cost optimization, such as provision throughput or auto scale or serverless? And what are for that?
Going forward, yes, certainly. But initially, when I was doing this in 2017, 2018, there were no serverless. There were less capabilities back then than there are today. So Cosmos DB has definitely matured in that way. And these capabilities, of course, are currently available, at least for a while. But back in 2018, when I started out, and in the beginning of 2019, they were less available. So I think the Cosmos DB did a great team in expanding and evolving the service also in different models, enabling also people with serverless to see how the service works without, getting this large amount of costs, so to say.
Cool.
Well, thank you so much for the presentation. I really enjoyed it.
You're welcome. Okay, thank you.
I'd like to introduce our next speaker. His name is Javi, and he'll be speaking about his company and his journey going through using Azure Cosmos DB.
Hi there. Thank you. Okay, so let's get started. Hi, everyone. Good morning, good afternoon, good evening, and welcome to my session. I hope you're enjoying the conference so far. My name is Javi Velasco, and I work as an API engineering lead at Vercel. And in case you're not familiar with what Vercel is simply the fastest way to deploy front-end applications. We enable collaboration by giving front-end developers comprehensive tools to build high-quality websites. Our mission is to help build a better web. With Vercel, you can connect a repository to a Git provider and instantly generate multi-cloud deployments that are globally available through our Edge network with every Git push. We have been using Cosmos since 2017 as our main persistency system, and it has been a really big part of our history since then. Being our main persistency, we have had a very intensive usage of it for both our APIs and the Edge network. And in the case of the Edge network, latency is especially critical, and Cosmos distributed nature has been a great fit for it. During all of this time, Cosmos DB helps us scale tremendously well from just a few million requests per week to more than 10 billion requests a week that we're handling today. Overall, we are currently making more than 1.7 billion requests a day to the database, and that's all scaled smoothly, keeping always a very good latency. So in this talk, we will see how we used Cosmos at scale in Vercel to work in a very performant way. And there is no better way to illustrate the journey that we have had with Cosmos than walking you through the wrapper that we have built on top of the Node SDK to optimize our access patterns. It started as a way to put together some code patterns that we required on a day-to-day basis, but later it evolved into something more complex that helped us to use Cosmos at scale and to solve problems that you might be facing today as well. This is a talk that I expect to be very useful for developers. We are running a lot of API services on Kubernetes, making an extensive use of TypeScript and Node.js, and of course, Next.js. If you're a developer working with Cosmos and these technologies, I'm pretty sure you're going to find this useful. Nonetheless, I expect you to find it interesting as well if you are a DevOps, SRE, or if you're interested in these technologies. So we are going to divide this talk into a few sections that can put together some of the features that we have been building over time. We will start by defining the reason why we have an SDK wrapper. And then we're going to quickly take a look into our observability tooling, which includes some primitive features that we've introduced back in 2017 to more recent and sophisticated tracing metrics. Next, we're going to see how we improve performance and reliability with some middleware-like features for our Cosmos calls. And then we will see how we enrich our data models, introducing a configuration layer that has been pretty much the cornerstone to more advanced tooling. And finally, we will close with some slightly more complex tools that we created to optimize access and guarantee cross-partition uniqueness of certain values that we called secondary keys. Finally, we will introduce a feature we call mirroring that helped us a lot when it comes to repartitioned collections. So let's get started. Why a wrapper, right? This is a typical scenario of any application that is using vendor libraries or SDKs. You're in control of your software, but not really in control of the libraries. It's true that you can browse them, you can fork them, you can PR, but you can't make changes that are specific to your domain. Forking is usually not the best idea if you want to keep leveraging maintainers' patches and updates anyway. So this means that you are in the end not really in control to do whatever you want to do with that code. And in our case, we have plenty of services that are using the SDK directly. So we would be sold to these cases, to these future changes with this model. We have to also consider that there might be cases where you want to add some extra processing layer to each SDK operation. So it is for this that we wanted to transition from this model to this other model. We would have an adapter between our services and the SDK, and that's going to dramatically reduce the amount of places where we have to make changes in the events of an SDK breaking change. We already lived this when we went through some major updates of the SDK. For example, when Cosmos 3 was released, it was shipped with some breaking changes optimization that we could very easily leverage with a very small effort, since we just needed to change our adapter. Another huge benefit of this model is that it makes very easy to inject layers and behavior on top of every database call. That is why, that is why we adapted every single Cosmos call to include layers that bring, amongst other things, observability. Our observability pipeline includes very simple tooling like logging, stats-D metrics, both introduced in 2017, and also includes some more complex tooling like tracing, which we implemented using APM. Now that we know that every single SDK wrapper is wrapped, we can introduce how we plug in these features. So assuming that you can generalize the contract of every Cosmos call to a lazily evaluated function that would end up resolving a response or a feed response, we can create a composition of higher order functions that would be adding layers with very specific behavior to every SDK operation. For example, in this case, in the snippet, what we are doing is bringing observability through two decorators. One is with stats emitter that would receive an event emitter through some provided configuration, and the decorator would use it to publish events with metadata. For example, it would tell how much time an operation took, what is the query that it ran, time taken, cost, etc. With logging is a much more easier one, and the responsibility would be to simply log a line to STD out before and after the operation happens. This log is going to be alerting on the cases where it becomes very slow or there are expensive queries or failures, so we can relate stack traces in our logs to potentially harming Cosmos operations. The stats emitter in particular was very useful because it allowed us to have a complementary panel in our observability pipeline that is showing pretty much the same as the Cosmos usage panel is giving in the portal, but with a very important difference, which is that in this case, we can define very fine-grained alerts when it comes to root consumption, for example. If it's going above a certain limit, we can set an alert, or if we have a very expensive or slow operation, we can also trigger alerts. Nonetheless, this is still working on top of the SDK request, but not from the requests themselves. So we are still blind and we don't know how much time is being spent on the SDK, how much time is spent in our wrapper, how much time that request actually took. So it is at this stage when it became very useful, a new feature that I think is still undocumented in the Node SDK, which is the plugins that is going to allow us to define for real a middleware where we can execute code before and after every single request happens. So we defined a tracer plugin that is going to work through APN and would start a span as soon as a new request happens and close it once the request is done, tagging and logging all error and all sort of useful information. Now, what is very interesting about this is that if we also trace our wrapper functions and the SDK functions, we can finally have a flame graph per operation that is going to show a timeline telling how much time each operation took. In this case, we are looking at a modified document by ID operation there in blue that we will see later. But for now, it is ignored by checking that it's doing 2 operations under the covers where the request is taking most part of it, but not all of it. This level of information has been proven to be of an enormous value, since it is extremely easy to find stalled requests and bottlenecks and errors. At this point, technically, we could go and to our previous decorators and replace them, but it's not really like subtracting value using these plugins, because there are still some features that we worked out in order to improve performance and reliability, for example, that are relying on the same pattern. So for performance and reliability, we followed a few strategies that are complementary to each other, and they are implemented in several different ways. The first one is adding a retry and a semaphore layer in order to improve our reliability on every Cosmos operation. As you can see in the snippet, they work in the exact same manner as the stat decimeter and the logger that we have already seen. With retry, it's going to give a retry strategy for errored SDK requests. Now, since 2017, the retry logic in the SDK improved a lot, and there is no strict requirement to have a custom retry layer for network errors anymore. But there are still some cases where the SDK request can fail, but still be retriable. For example, when the write session is not available. This has been very useful for such cases. We also have a layer that adds a semaphore in front of all of these requests. And this is going to help us making sure that we don't take the event loop. It helps controlling the concurrency, how many operations are going to be running at the exact same time. If we do, for example, a promise all with thousands of operations at the same time, we will make sure that we are not taking the event loop and we are not running a lot of operations in the exact same millisecond. With this, we complete all of the decorators that we have in front of every single operation, but there are more interesting things that we did to improve performance and reliability. In our experience, when we are reading a document and that is taking more than half a second, it usually times out. This has to do with the Cosmos gateway being too busy, and usually a simple retry is going to help in this case. We have seen it so in our observability pipeline, many cases where a request took exactly the timeout that we have set plus 1 second back off plus a few milliseconds. And this is precisely because the very first retry is going through correctly. So a good strategy to overcome this issue is to have an early timeout strategy for the first try. That timeout can be increasing with the next retries, but it is very important to know that it has to be tied to each operation. For example, reading a document is not going to take the same amount of time as a query, so we can be that optimistic. It is for this that we defined a plugin in a similar way that we have seen for the tracer that allows to pass a times out policy to our wrapper, where we can specify not only the timeouts that we want to get in a sequence, but also the amount of retries and the backup strategy for each of those. This has been very, very useful for us, and it helped reduce dramatically the max time and the P99 in our APIs. Another one that is one of my favorites when it comes to reliability in our system is the ability to perform safe updates, avoiding race conditions and potential data loss. In systems where we are processing, like in ours, thousands of requests per second, and we have spawned jobs that are processing and accessing and mutating the same data concurrently, there is a very high risk of overwriting data because of race conditions. Say that you have this scenario where you are reading a document and then you update the document locally and then you push the mutation to the server. The chances that the item was modified by the time you push are very high and can lead to data loss because you are updating stale data into your system. REST APIs solve this with versioned resources using e-tags, and Cosmos works exactly in this way. So we wanted to bring this behavior to every single API, every single place where we were pushing changes for a document, and retry in case we got an error with the e-tag. So we modeled this high-level tool, modify document by ID, that would help us in those scenarios. It works just by receiving the collection name, the document ID, and an updater function. So what it's going to do is it's going to read the document by the ID or the information that is provided, and then it's going to apply that modifier updater function. If it performed any changes, it's going to push the change. And in case it fails because of the ETAG or the resource version, then it's going to retry and apply the function again. This was really, really helpful for a use case, and it helped us to be super sure that we are not getting into this trouble of overriding data with stale data. So now let's see how we enriched our models and brought a declarative way to express what our collections look like. In this section, we're going to see how we define features that are present in other databases and are essential to operate Cosmos in production, in my opinion. The first and most important of those is timestamps. There are many databases out there that have out-of-the-box support for timestamps. Those are going to tell you when a transaction took place, when a document was created, when it was last updated, and in some cases when it was deleted. So since we have this SDK wrapper that runs on top of every single mutation and operation, instead of going to every single place and add these fields to different documents, we can just put it in our wrapper. And it is worth mentioning that this is very useful for sorting information, so sorting records depending on when they were updated. And Cosmos includes already an attribute for this, but you can opt out from updating that attribute when you push an update to a document. And we wanted to have that feature, which is why we implemented this. Another one that is very closely related to this is soft deletion. We never remove data for real. What we do instead is that we store a timestamp that is going to tell us when an item was deleted. The reasons why we have this is actually very obvious. Removing data for real is very risky. And in case that you are rolling some regression or some buggy code, you don't want to just remove data in an unrecoverable manner. In the snippet, you can see how we usually remove documents. We just set a timestamp through a wrapper function, and from that point on, we are going to ignore those documents. Of course, this comes with a cost, because every single query is going to have to include automatically a predicate to leave all of these records outside of every query. Of course, this behavior can be opt out. And this doesn't mean that we are keeping records forever and ever around. We have some pruning processes that are going to be removing data after a safe period of time, depending on the entities that are going to be cleaned up. So another thing that we didn't mention just yet is partitioning. In Cosmos, is very important to partition collections correctly. And it is something that obviously we didn't do at the beginning. In our wrapper, we automatically use the ID as the partition key because all of our collections were partitioned by ID. So when the time came that we have to use a different partition key, the wrapper just didn't know how to inject the right partition key. So we decided to create a very simple configuration object that would enumerate all of the collections that our system has and what their partition IDs were. This enabled us to do very interesting things aside from injecting the partition keys automatically. In the snippets, you can see how we are just enumerating collections. We're going to be referencing later those collections rather than hard coding the strings, and we can define their partitions. On the case where we have a configuration object like this, and we are running a cross-partition query through a helper, what is going to happen is that we can analyze the query, and we can see if the partition key is actually being included in the query. With the SDK version 3, if the partition key is included in the query, it's going to work in a very efficient way. But if it's not, it's going to be doing a cross-partition query, and that is going to be a very costly operation. So we wanted to make developers very aware of this fact and force everybody to into the awareness of making cross-partition queries. So we have managed to use this configuration in a way that it throws a asynchronous error if you are running into a cross-partition query without specifically telling so through a flag. This helps us save a lot of cross-partition queries. And related to this configuration, everything fell into place when we started building a testing framework that would use our in-memory replica of the Cosmos DB server. That link that you're seeing there is public, and you can access and use it today. It is a Cosmos DB server that works in memory, and it has pretty much the same API as the one you use in production. So in order to set up this server, we obviously need to create containers, create user-defined function, composite indexes, and so on. Because we already had a configuration for the wrapper with all of this information, we just needed to enrich it a little bit in order to generate the database server that is suitable for our schema. Even though those properties, like unique keys and composite indexes, are not really used inside of the wrapper, it becomes very handy to have them around, because you can just have a look at your configuration and have a very high-level view of what the schema looks like, and that all respecting the schema-free and flexibility of the Cosmos database. So this was an incredibly useful feature for us. In our testing pipeline, we have this in-memory server that boots, clears, and then self-configures automatically for every single test. From this point in time, testing became a matter of creating a bunch of documents to reproduce a scenario, run the code, and then run the assertions. And we didn't have to think about setting a server anymore. As a matter of fact, this gave us the idea of a feature that we called database snapshot testing. So based on the configuration, it would be very, very easy to have a function that would go through every single collection, querying all of its information and creating a sorted object that you can use to retrieve the whole state of the in-memory database. So that way, testing becomes a matter of preparing the environment, doing a get on this whole database state, and then running the effects, getting the state again, diffing, and snapshotting that everything is working as expected. It is a very handy way to test side effects. Yeah. So the next important feature that I want to talk about is that what we call secondary keys. And this is one of the most important that we have faced in our journey with Cosmos. This was crucial for us to minimize the amount of cross-partition queries and to ensure unique values across different collections and partitions. Say that you have a model like this with users and teams. The user is going to hold some data that in a relational database would be primary keys, like values that are unique to the system and can be used to index the entity. On the other hand, you have a team that also has a couple of keys, like the ID and the slug. Now, what is interesting about this use case is that we want the username and the team slug to be in a shared namespace. We want them to be unique, even if they are documents stored in different collections. Besides that, we need to have an optimal access to users and teams using their unique values. When we choose the partition key, we would say that it is the ID in these cases because it's the most common access pattern. But still, we're going to have many places where we need to find a user by email, for example. And that's going to be a cross-partition query that over time can be very, very damaging. So how do we solve this thing? This is why I said that the configuration was like the cornerstone of this advanced tooling. We just added some configuration values that would tell what are the secondary keys in our system. For example, for users, we will say that the key email and the key username are going to hold secondary keys. And we will say what is the collection where we want to store what is going to represent the key. Then optionally, you can also give a namespace to make sure that you can have living keys in the same namespaces that would collide with each other to ensure uniqueness across usernames, and slots in that case. Of course, when we run now create document, the downside is that we are going to be creating not only one document, but also documents for the keys themselves. Those keys are going to keep information about the original collection, the original partition key, the original value, etc. So what is really great about this thing is not only that it is allowing uniqueness, but also when we get a document, we can have a helper that is going to get documents by keys or no. You can simply tell what is the collection that you are accessing, what is the key that you want to access, and what is the unique value. And instead of doing a cross-partition query to retrieve that value, we are going to do 2 consecutive get documents by ID that can be up to 50 milliseconds, which is much, much, much better than a cross-partition query. Of course, there are still 2 reads, but I think that the balance is pretty good overall. The most challenging part about this is that we had to model sort of transactions. We don't have transactions like we mentioned around this morning. So we had to be very careful when modeling this to make sure that if there is a failure, we could roll back the changes that we already done and we don't leave stale data. Still, we left some other tooling in place for reindexation and to make possible eventual consistency and self-recovery. The last one that I really want to briefly just mention is mirroring. Since our collections were not correctly partitioned from the very beginning, we had the need of switching them at some point. So in order to figure this out, we added some more configuration that would tell that a collection has to be mirrored into a different collection. And when any mutation happens, creating a document, modifying a document, anything, the outcome would be published to this other collection. So as soon as we roll a new version with this configuration of our SDK, of our wrapper, everything is going to be populating automatically. So the only thing that is left is just to run a backfill function that would create all of the remaining items, going through each of the items in the collection into the new collection with the right partition. Then we reach the point where we have one-to-one documents between both collections, and the only thing remaining would be to switch reads to the new collection. This was very, very helpful, and it helped us to correct our data in production without downtime and remodel our collection. Of course, there is much more to this. It's a very condensated talk, so feel free to reach out and discuss ideas and any other questions you might have. And if you want to help us build a better, faster, more scalable web, we are hiring. So reach out to bersel.com/jobs or ping me directly in Twitter at Javi Velasco. My DMs are open. Thank you so much.
Thank you so much, Javi, for a great talk. I really liked how you really focused on how the wrappers help when there's changes upstream done to the SDK and you want to kind of protect your users and protect your apps and decide how you want the change to go downstream to your applications. It gives you a lot of flexibility that way, and I thought that was really cool.
All right, thank you.
One question we got from our users was, are there cases where you don't want to use wrappers, where it's not worth doing so because of performance or some other reason we're not thinking of?
Right. I think that in general, in every API that is out of your control, but not necessarily just tooling, but more like SDKs. For GitHub, for example, and other Git providers, we are also having like our own clients that sometimes are relying on their SDKs and sometimes are just doing raw request. In those cases, if some new change comes, some new API, experimental API comes in, we don't even have to wait for them to roll those into the SDK. We can just go and implement it our own. That is very cool. Cases where we don't really need this, I guess that if you're using a library that is very lightweight, like for example, if you are using in Node.js, it would be something like Lodash or Ramda or something like that, that is very, very minimal. Those cases, they are just helpers. So there is no really actual value in having a wrapper on those.
Okay, great. So it sounds like assessing the value is kind of like a balance between are we getting any benefit out of putting this layer between for our users?
Yeah, and the primary one, the most important one, I would say, is observability. If you have a synchronous function in JavaScript, for example, there's no need to observe that usually. Depends on the size and what it's doing, of course. But if you are doing under the covers some network requests, like for example, something that we have found very valuable is that the SDK is doing its own retry strategy under the covers. So if we just wrap it and we just trace that, we are going to see in the end how much the SDK call took, but not how much the request took. So that is why these plugins were very, very useful. And this actually extends to other SDKs. You can maybe disable the retry strategy if you are not so sure about it, and put your own in front of it, where you can also instrument proper observability. So I think that's very helpful. Yeah.
That's great. That makes a lot of sense.
Sorry, one more question. Thanks so much, Javi. I really enjoyed this presentation. Definitely a model partner here on how to use all of the functions, all the things we have available. Quick question. You mentioned that for partitioning, you had the wrong partitioning strategy. How important was observability in diagnosing, hey, maybe I have the wrong partition here?
Oh, that is a very good question. Thank you. So once we have the observability is when it actually started popping out. The first thing that we have seen back in 2017 was that when we were running cross-partition query, we added this wrapper that was just the logger. That was a very naive implementation. But then we visited the logs of a very critical service. And for every request, we have seen like thousands of log lines. So that actually revealed that there was an issue there. We are using an access pattern that is very required to be fast and optimal, and it was really terrible. So that is one of the ways that we discovered that. Then when we got something more sophisticated, it was even more explicit, because you can actually see the flame graph showing you a lot of tiny slots with every single request that it is doing under the covers. So observability was super important for that. And this solution that we came up with, the secondary keys, was very, very helpful, especially in our dashboard when fetching users. We had very common use cases where we needed to fetch a user by email while the email is not the partition key. So how can we do that, ensuring uniqueness and ensuring that it works in a very fast and efficient way? It was very difficult. And in a previous talk, it was mentioned that since you're lacking transaction key because you are using a NoSQL database, you have to implement our own kind of transactions. And that was a very challenging part, but it's definitely worth it.
Okay, awesome. I actually had a bunch of questions, but we're not going to have time for me to ask them. So maybe I'll reach out to you, Javi, and I'm sure others will as well. There's some really cool features that you built there, so that's awesome.
Thank you.
So thank you for that. And I believe we have now reached the last session of the Azure Cosmos DB Conf 2021. So thanks to all the speakers that have gone before. We have one session left, and I'm delighted to welcome Gary and Amrish from our friends ASOS, who are going to talk about operational triumph with Azure Cosmos DB. Take it away, Amrish.
Thanks, Theo. So hello, everyone. Some really great sessions today. I definitely learned loads. So hi, I'm Amrish. Welcome to our session on operational triumph with Cosmos DB, where we'll look at how ASOS has been using Cosmos DB to achieve success. I'm a solution architect here at ASOS, looking after the order and return domains. I've got here with me my colleague Gary, who will introduce himself.
Hi, I'm Gary Strange, big data architect at ASOS. I work alongside Amrish and other architects delivering data solutions.
So a little bit about ASOS. So ASOS is a globally distributed online fashion retailer whose aim is to be the #1 destination for fashion-loving 20-somethings, providing a market-leading app and web experience. Since its official release in 2017, ASOS has been using Cosmos DB and all of its different features to reimagine our commerce platform, from millisecond SLAs to the turnkey distribution and infinite scaling potential. So let's look at how Cosmos DB has been vital to our, to be able to conquer our operational data needs, while remaining flexible for peak periods such as Black Friday. As everyone knows, we operate at huge scale and at a global scale. So let's take a look at some numbers just to understand what that really means and how we use Cosmos and the rest of the Azure ecosystem to help us achieve that global scale. So we offer our app and web experience in 10 languages across 200 markets. We have over 85,000 products on the site at any time. 5,000 new products added every week, and we have an active customer base of 24.9 million customers. In the financial year 20 just gone, we actually processed 80.2 million orders. Let's have a look at where and in our ecosystem we use Cosmos DB. So we use a microservice architecture, which is made up of many, many services, some of which you can see on the screen today. So our order service being the one that where customers can place orders, our pricing system where we can manage our prices for all of our different products, our payment service, which we use to take payments and transact with all of our different payment providers, stock and fulfillment services, where we can manage stock availability, as well as manage integrations with carrier management systems and various other aspects of fulfillment. Our promotional system is heavily utilized, especially for usage, and we use Cosmos heavily in this area. Our saved item service is one of the largest consumers of Cosmos DB and provides a fantastic experience for customers where they can save all of the different items that they want to purchase, or they can create boards and share them with their friends and family. We're going to look at why we use Cosmos DB, just to better understand all of the different aspects around why we prefer this. So first and foremost, we love PaaS, and Cosmos DB being a platform as a service offering helps us reduce our operational overheads, as well as being cost optimal when we want to run our production or most mission critical workloads. We love nines here at ASOS, so the fact that Cosmos DB can provide up to 5 nines of availability is a huge deal when it comes to providing that great customer experience that everybody knows us for. Being schemaless provides us with business agility, being able to adapt and change to business requirements and environments. It's scalable and highly performant. The geo-distribution of data, the data partitioning is made easy, because provides it out of the box, and we don't have to think too carefully about this. But having a great partitioning strategy is super important. The latency guarantees on read and write operations helps us focus and fine tune all of that performance that we need down to that 10 millisecond SLA. The change read has been a real game changer for us to adapt and reimagine our architecture, especially in the commerce area. Next, we'll look at a use case around order management and how we can utilize Cosmos DB to re-architect the system to be operational globally, as well as being resilient and scalable and highly performant. So now that we know where and why we use Cosmos DB, let's take a look at the order service in more detail and how we can leverage Cosmos DB to build a cloud-native event-driven order processing engine in Azure. So the first thing that we did is we broke that capability into 2 logical parts. The first being our order booking capability. Here it's super important that customers can continue to keep placing orders and is available globally, so that even in the event of a regional outage, we can continue our operations. So Cosmos DB provides all of this capability to us with that industry-leading geo-redundancy and multi-master write features. Next, once we've got all of that data, we can persist all of those requests into an Azure Cosmos DB. And then once that is there, we've got the change feed capability, which can then hand off to our order processing capability. So let's have a look at order processing. So order processing, we've re-architected or are continuously re-architecting into a serverless event-driven architecture. Here you can see the change feed processing those orders coming in, emitting out an event. And once that event is published, it goes on to our Azure Service Bus namespaces, where a whole orchestration and workflow is managed between all the different microservices that we have, whether that's stock allocation, whether that's payment integrations, whether that's fulfillment decisions, discount approvals, fraud, and the list goes on. And all of that is highly scalable. We can adapt and change that workflow however we want. And all of those events being published generates a huge amount of data. And all of that data can be event sourced into a Cosmos DB, where we can then project out our read models and provide insights to the business to make decisions on how we want to improve performance or change the way that we operate. So all of that, is really, really great, having lots and lots of data. And you can see here that Cosmos is fundamental for us to be able to achieve all of that. Now that we have the data, we need to provide some insights. And so I'm going to hand over to Gary, who will just talk us through the ASOS data journey. Over to you, Gary.
Thank you, Amrish. So we've had a lot of success with Cosmos DB in our operational microservice domains. However, as technologists, you'll be acutely aware that we need data and data analytics to drive future business success. So in the second half of this session, I'm going to present and share with you some of ASOS's data journey and what we've learned along the way, and why we think Cosmos and Event Hubs is actually a really great combo. So any data journey has to start with some data pipeline and ingestion. So I'll start there, big data ingestion. So we've got this diverse family of microservices backed by Cosmos DB. And they're transacting high-value enterprise messages between each other. And we need to tap into that rich source of data and bring it into our enterprise analytics function. So we started that journey a few years back, and we've learned a lot along the way. And before I get into the journey, I just want to kind of dig into a little more depth on what I mean by an enterprise analytics function. So we need to drive analytics through data, and then we need to deliver on a number of facets. So what is high-stake analytics? Well, we use large volumes of data to train machine learning models and develop pricing strategies. And this gives the best price point to customer. We're an agile business. We're very agile in our approach to technology. So we want to be able to iterate quickly and deliver small changes and observe feedback on and get early results. For example, A/B testing. We want to be able to make sure that the business is healthy. So we want to know that our customers are satisfied and they're getting the experience they expect from ASOS. And when we're running promotions, we need to understand in real time that the promotion is working effectively, and we can make tweaks as the promotion is live. And we want to optimize our business. We want to try and manage our return rates, make sure we're not having too many returns on products. We want to make sure that our marketing spend is really effective. And finally, we want to grow our business. We want to continue to grow our customer base and convert product searches into purchases. So at the beginning of our big data journey, we relied on the convenience of that existing microservice architecture that Amrish has explained for us. And it was simple enough to sort of plug in newly created ingestion services into that existing microservice infrastructure. And I'll just explain quickly about how fundamentally these microservices generally operate in two modes. So on the diagram here on the left, we've got a fat message-based architecture. So document entity changes in microservice A and microservice B needs to know about that. The full entity is pushed onto a queue, and then we have the subscriber to that queue that needs to take another action, the second microservices. And then in the diagram on the right, we've got fin event. So customers change their profile or add something to bag, we just send that event. We say, oh, they changed their preference. They put product X in their bag. And then if the subsequent microservice needs to know about the complete state of the bag or the complete state of the customer profile, they'll make an API callback. So as I said, we plugged into these two flavors of microservice architecture, and that got us going in the early days. But however, we quickly discovered there were some cons to this approach. So the one big pro was utilizing existing assets, Azure assets and infrastructure, but that also came with a con because we didn't really properly segregate our operational infrastructure from our analytical workloads. And we want to have that segregation. We want to be able to have effective management over our mission critical microservices. There's a lack of consistency across APIs. So we're very, as I said, we're very agile with our tech. We have a lot of autonomy within the teams. So not every single microservice is well, let's say they have all their nuances and their specialities. They can be quite diverse. So to integrate with each of them wasn't necessarily plain sailing. And then we could only tap into messages that were available at the time when we created the integration. And as I said, we've got situations where we'd like to look at a large, deep volume of data to train a model or do some deep analytics. So that back data simply wasn't available via plugging into the existing architecture. So it was often an additional piece of engineering to go and ask and coordinate with the source team and say, all right, we want to get the 3 years of back data out of your Cosmos DB. And that was challenging and a throwaway piece of work. And then also when we had an interruption service on the analytical integrations, and perhaps we'd missed some messages or lost some messages and are unable to attain crucial messages, we'd have to go back and say, we've missed these messages, we need them, we're missing data. And then that would also be not a non-trivial exercise to try and get access to those historical events, those historical messages. So before I talk about how we our journey on addressing some of these cons, I want to talk a little bit about boundaries and ownership. So a naive approach might be to say, well, we'll build some ingestion services, we'll have this centralized data team, and they'll reach into the operational stores and pull off data and as much data they need the data to hydrate data stores for the analytics functions. However, this really doesn't separate the operational and analytical concerns, and I can assure you no team at ASOS will allow another domain to simply dip into their operational systems. They want to have the control and management over those systems. So with this understanding, what we learned from where we started from, we came up with some integration objectives that we'd like to incorporate in a new approach. So firstly, we wanted to access these rich sources of data from an offline state. We don't want to be interacting directly in any way with that operational Cosmos DB because it's so mission critical. We can't take the risk of interruption to service. We want to be able to replay data from an arbitrary point in time. So again, coming back to that scenario where we need to go back in time and get huge volumes of data, we wanted that to be quite a seamless activity, not a big engineering exercise. And then as I said, we want large volumes of data, but we also want to be able to look at more real-time signals, as I said, monitoring the performance of a promotion and other signals and behaviors of what's happening now in the business. So we want that fast layer as well. So we want both fast and batch access to data and develop a Lambda architecture. So that led us to a conceptual model. And before I get into this slide, it may look like there's a ship stuck in a very narrow canal, but that wasn't what I was trying to do. And I actually built this slide long before the Suez blockage. So let me explain. So on the left, we've got the microservices. They're very, as I said, mentioned, very diverse family of microservices backed by Cosmos DB. And what we want to be able to achieve is that those microservices take the responsibility of taking their data and the nuances in their services and packaging that data into boxes, into uniform containers. And if we can get each one of those to take their special data and put it into boxes, the operation of taking it from the operational domains to the analytical functions becomes very simple. It's going to take box from source A and we stick it in destination B, and then for each analytical function we open the box up and we pull out the data we want and use it to drive those functions. So that's conceptually what we want to achieve. And then in the next slide, I'm going to talk to you about how Cosmos ended up being quite a big hero in delivering a sort of a cloud-based solution to that conceptual design. So I'll just talk through the architecture here. Through this high-level diagram. So Cosmos DB on the left there, backing our mission-critical, highly available microservices. And then we can access that change feed, as Amrish mentioned. And what we do is we use an Azure function to take a dependency, a trigger dependency on that change feed. And every time a document is created or mutated in the Cosmos DB, we get those messages, that fat state coming through, and we play that onto the Event Hub. And then what that gives us, once we've got those messages flowing through onto the Event Hub, our enterprise analytics function can now say, right, I can access this operational data, this high value data through two channels. It's by channel. So in the batch channel, we can use Event Hub change data capture that's continuously listening to the Event Hub stream, the messages, and just running it out to blob, continuously packaging it up and put it in a blob container, and that's completely configurable. And then when we want to look at the sort of more real-time signals and want to know what's happening right now in the business, we can use Stream Analytics to also very frictionlessly hook into that Event Hub. And that all happens completely away from that operational Cosmos DB. And you see that the domain boundaries here are very deliberate. So we want the source team, the team that looks after that mission critical microservice, to have the management control over that Azure function, have the management and control over the event hubs. One, so they can control the throttle, the workload on that change feed. So they can observe the pressure on the RU and make decisions about whether they need to upscale or downscale or turn off that Azure function. And then they can also manage the event hub and who can have access to the data. And so you've got the access control model. And I wanted to really highlight here a really neat little toggle that's available when you create an Azure function that's going to listen to a change feed trigger. And you configure this start from the beginning toggle. The default is false. It will just start reading the change feed as and when it starts up and it's live. But if you toggle the start from the beginning, actually you're saying, okay, when you create your leases to read that change feed, I don't want you to start reading the change feed now, what's going on now. What I want you to do is I want you to start right from the beginning, the earliest event, the earliest documents in that container, and then just play through. So if the Cosmos DB's been there for a year, you'll start with the very first record that was created a year ago, and then just play through, and eventually it catches up, and then you'll read in the here and now. And the nice thing there is that actually through one piece of architecture, through one piece of development, we get the two things we're after: that volume, high value enterprise data, and what's happening right now. And they come through the same system, through the same piece of cloud infrastructure, and we get our by channel output. and this has been highly effective and successful at ASOS. So for example, we processed 3 years of data from one of our mission critical systems in just a few hours, with one engineer sort of managing the change requests and the release, and observing and taking control and making sure that it all flowed through nicely and there was no interruption to service. And that's the sort of thing we love, being able to sort of do that low effort capturing of data. And now, so I talked about specifically about the approach in a sort of macro level, but I want to talk about now about how that works at scale at ASOS, and how this helps us decentralize some of the enterprise analytics responsibility. So here it's very similar to the first slide earlier in the session. So for each microservices, they adopt this approach. They pulling or pushing the data from their Cosmos DB to Event Hub, and then from there, the enterprise analytics function becomes much simpler. We've got this bi-channel output from all these rich sources, and we can just say, right, for this use case, we can tap into these microservices and we can get real-time data. For this use case, we can tap into this subset of microservices and hydrate this deep analytics system or this machine learning model. And what effectively we've done is distributed some of that effort, some of that responsibility away from, like, I guess, a stereotypical data engineering, data analytics team. And therefore, and we've placed the control and the ownership and the management in the right place. It should be with that team that's looking after that mission critical Cosmos DB. That they need to manage it. They need to make sure it's highly reliable, highly available, and the function of capturing this high value data doesn't mean an interruption or a risk to interruption to service. And this sort of takes us on our early steps towards becoming more of a data mesh orientated enterprise analytics department, I guess. So yeah, that concludes the session today. I hope you enjoyed listening in, and I think if we've got a bit of time, we might be able to go over any questions that may have come in.
Yes, thank you so much for the session. It was really great being able to walk through where you guys started from the beginning of your architecture and kind of decoupling those services from the operational and the transactional sources. I'm sure there's probably less supportabilities tickets coming in since you guys have kind of given each of your feature teams the responsibility of ownership for that. Is that right?
Yeah, that's the idea, is to try and decentralize some of that effort, that responsibility, because the inverse of that is one big team that has to take on all these relationships and build all this maybe integrations, and it just becomes a funnel, and in decentralizing we get the scale of effort.
Nice.
Awesome. Amrish, I know you mentioned at the start that change feed was game changing for you, and Gary, you took us through a few of the features of change feed. I wondered if you wanted to maybe pinpoint or articulate what it was exactly about change feed that had made such an impact for you with what we've been doing.
Yeah, so essentially, because it's an event-driven system, we wanted a way to be able to read the log from any point in time. And the other thing is, we also wanted it to be able to be scalable. So the fact that we've got a constant changing system with lots of requests coming in, and the fact that we have a log of all of those different requests coming through, meant that we could actually have competing consumers in two different regions, all processing from a single change feed if we wanted to, or even in a single region. And that gave us the scale that we needed to be able to process all of these things in a timely manner. And that was one of the most appealing aspects of this. And the fact that you could, like Gary touched on, that you could reset the pointer back to a previous point in time was a really good way of us managing that replay capability that you would see in a typical event-driven system as well.
Yeah, I guess just to add to that, we love the control that you can get with the change feed, as I said, and I think you mentioned, that decoupling. So yeah, maybe we're in a position where there's too much demand on that operational system, and we can actually just switch it off. Okay, right, well, let's just switch it off. We don't, analytic feeds is our secondary concern. Mission critical availability is our primary concern, and then we can switch it on later, and it's kind of like we just pause time. That's all we do. We don't have to do a whole healing of the system. Just switch it off. Okay, we get over that hump, switch back on, and we replay from where we were. Gives us a lot of agility, a lot of control over the movement of data between systems.
Going back to the team decentralization and how there's different teams working in different sections about microservices, etc. Do you have any tips on how to ensure that knowledge transfer is transferred between the teams, so we don't have two teams working on the same thing, or if someone wants to work on something else, they don't have to relearn everything from scratch, sort of things?
Yeah, I guess sort of domain knowledge transfer is a big challenge actually across the enterprise. And I wouldn't say there's no silver bullet to it. I mean, a lot of it is actually building excellent internal relationships and being able to reach out to people and for people not to feel like they can't make contact or find the right people to talk to. So it's all I describe some of our role. We might be technical architects, but I do feel that we actually play a role as being cultural architects and try and galvanize those relationships and open those pathways and make sure that that knowledge transfer is achievable with not too much friction.
That makes sense. Thanks. Any other questions that we're seeing? Stephanie or Theo, if not, all right.
I think that's it. Yeah.
Okay.
Thank you.
Thank you. Yeah.
Great.
Thanks,
amazing.
Yeah. That was really good. Thank you. Right. So what did we think of everything we've just seen? I was really kind of blown away by how much intricacy there is in what people are doing out there. They really found creative solutions to problems and leveraging features in Cosmos DB in a very sort of creative and impactful way. Especially, I mean, I'm thinking about the tooling that we saw at the start for Infra's code and the Javi's tooling and SDK features and so on. What do you guys think?
Especially around the observability aspect, I thought that was really interesting. They had a need that they had, and they found a solution that worked for them, and they managed to improve performance and just improve usability in general by and partitioning, especially by coming up with this tool that worked for them. And I can see a lot of I guess the word is synergies that can be applied across many different users using these kind of things. So it's great to hear about that.
Yeah, just really created a lot of transparency for the user and a nice little abstraction there. And these are common things that we see customers doing day in, day out, and they just thought about every single one of them and created a nice little feature that helps. So that was cool. And there was a lot of theme around change feed or around streaming. So services, you might get the impression that this is a good database for microservices if you're watching this, and you probably would be right. And so it just seemed that we had a lot of those conversations and things coming out.
Yeah, and not only that, but data modeling. I think that was a big theme during the conference, is how important actually modeling your data in the beginning is to the overall integrity of your applications, because you'll have to then restructure a lot of things. But it's important to take time to really model your data over time. What do you think that this would look like, and come up with the best strategy moving forward.
Yeah, I really loved Pascal's slide. I'm going to steal that slide. It was just so straightforward, but this idea of it being a very much application-centric process. That your application design drives your data model, and then that drives what you produce, as opposed to data model and then build your application on top. It's just a complete mind shift, and it was just a very simple way of representing that. And that's what we see, isn't it? We see developers drawn to this type of development, and they are much closer to the data model. It's just a natural fit. It seems like more of a continuum as opposed to a kind of we'll design the data model and then throw it over to the developers afterwards. So that was a really good way of summing it up.
Yeah. I totally agree. I really like that slide. That really summed it up, because there's different groups of people who can benefit a lot from Cosmos DB, and people from the relational world, and people who are just learning about NoSQL who don't have any prior database experience. So it's really cool to see the path that they would take in either route, and what's the correct way to do things with NoSQL.
Yeah, definitely.
Another thing I really enjoyed seeing was how our users are utilizing other Azure services to really make their experience as best as it possibly can be, without them having to manage all of this infrastructure on premise or on their own on VMs. Like, they're just doing this in a serverless kind of way with Azure Functions, and connecting that in the 3 different ways through measuring changes, or through the other 2 ways of doing that with Azure Functions. So that was really interesting to see.
Yeah, awesome. Okay, so it looks like we're at time, so I'm going to close up here. And just again, a huge thanks to everybody involved with the conference. Just been really awesome, and the presentations today were I'm literally blown away by the quality and what people are out there doing. So just some last things to say. If this was the first stream that you watched, there are 18 on-demand sessions in addition to the live sessions that you can get, with even more amazing content that's built by our community. If you want to watch those, you just head over to aka.ms/Cosmos DB Conf. Hopefully that's appearing in the banner, and click on the agenda for the event. You'll see what's there. Another thing would be, if you've not already, join us for our weekly podcast. So our host, and also the mastermind behind this whole event, Mark Brown, meets with members of our team, as well as members of the Cosmos DB community, to dive into a new topic every week. So if you want to see a podcast live or watch it on demand, head over to aka.ms/Cosmos DB Live TV. Hopefully that should be coming from the banner as well. And finally, if you're new to Cosmos DB, this is the first time you've ever heard about it, and you want to find out ways that you can try it out for free, read our blog post at aka.ms/Cosmos DB-free. And you'll find out 4 different ways you can try Cosmos DB, including the free tier, where Cosmos DB will be free for the life of the account. That's free, so no excuse not to try it out. So yeah, again, thanks for joining us for our very first Cosmos DB conference, and we hope to see you again next year. Thank you.
Thank you. Bye.